Tonight's topic is Materialism and Theism. Do fine-tuning arguments succeed? Our first speaker is Dr. Luke Barnes. He's a postdoctoral researcher at the Sydney Institute for Astronomy. He talks very funny. His university medal from the University of Sydney helped him earn a scholarship to complete a PhD at the University of Cambridge. He's published papers in the field of galaxy formation and on the fine-tuning of the universe for life. He's been invited to speak at the 2011 and 2015 St. Thomas Summer Seminars in Philosophy of Religion and Philosophical Theology, the University of California Summer School for the Philosophy of Cosmology, and numerous public lectures. His book, with Geraint Lewis, A Fortunate Universe, Life in a Finely Tuned Cosmos, is available from Cambridge University Press and that table right back there. He plays cricket. It looks like baseball, I think. And some rugby. That's real football. And has a wife and 2 kids. Please welcome the man who traveled the furthest distance for this event, Dr. Luke Barnes.
Cheers. 20 minutes? Sure. That's not my beer. Let me first reassure you that I do indeed look like a cricketer. Let me get my clock out. All right. Nope. Yep, that button. There we go. Good. Well, thank you very much for coming out. I've got a very, very good feeling about this. There's been 3,000 years of debate about the existence of God, but I've got a really good feeling about tonight. I haven't done a debate since my Year 9 class, well, the 9th grade class, failed to determine whether animals should be kept in zoos. But I've got a really good, tonight, we've got this. We just need to commit ourselves to stay here until we sort this thing out, all right? We're going to lock the doors, we've got beer, let's just stick it out, okay? Actually, if you've watched any debates like this, you'll know they succeed if you guys end up thinking more about this topic and more deeply and in a more informed way than when you came in the door. So I sincerely think that's going to happen tonight. So on that thing, it'll probably be a success. After this, you should keep talking to your friends, keep talking to people who disagree with you, maybe read a book. I've got a suggestion for you. All right, let's get going. Materialism and Theism. Do fine-tuning arguments succeed? Let me define what I mean by those terms, and we can talk that through later on. By materialism, I take to be the positive claim that natural stuff, that material stuff is the only stuff. So everything that exists concretely, as opposed to abstractly, is made out of material stuff, or is that material stuff. So I tend to use the word naturalism. If I slip and say that word, I mean the same thing as materialism. Theism I take to be the claim that a perfectly good, maximally powerful, and necessary being exists, who we call God. Though God isn't made of material stuff, God made the material stuff. I think I need to give a little bit more of an introduction to what I mean by that character, just because when you say God, a lot of people tend to think of a sky fairy or a beardy man in the clouds or some sort of cosmic Santa Claus. One way to get a better idea, I think, about what most philosophers and theologians have meant by God for the last couple of thousand years is via what's called the Cosmological Argument. I'm using this just as an introduction of the idea. This argument actually predates Christianity. The Greeks used it. If you understand the logic of the argument, even if you don't think it's successful, I think you'll get a better idea about who this God character is supposed to be. So let me start with an analogy. All right? Analogy. Okay? I'm currently standing on this stage. It's made of wood. The stage is on a floor. There's probably some concrete foundations under there, which is on some, what do you have out here? Clay, which is supported by some rock, and down we go. Now, there's something odd about that situation. If you take any of this stuff and you hold it up and you release it, it falls to the ground. It's all falling kind of stuff. And if you keep going down and pick up a rock, it's still falling kind of stuff. So there's the question, why isn't everything falling? Here are three possibilities. Maybe there's an infinite amount of falling stuff as we keep going down. Just keep going, it's all the same stuff, and each layer is always supported by one below it, and so that's the explanation. Now that doesn't seem like a particularly good explanation, for the reason that an infinite amount of stuff could still fall. Right? It could support, but it could also fall as well. So we haven't really answered our question, why am I not falling if we're all made of falling stuff? Number two, perhaps there's a magical floating layer. Maybe there's a layer made of stuff that would ordinarily fall, but for no reason at all, that stuff isn't falling and can support everything above it. That seems like a pretty ad hoc suggestion. Number three is that there is a self-supporting layer down there. There is something down there that is a different kind of thing. The question, why doesn't that thing fall, has an answer, and to stop the infinite regress, it's in terms of the thing itself. Now, I'm an astronomer, so I feel I can inform you that number three is correct of us here. But note well the logic of the argument. To explain why things that could fall don't fall, we need a new type of thing, something that cannot fall. So if you just, for the moment, ignore the rest of the universe and think about the Earth in isolation, the center of the Earth can't fall because it defines the place that everything else is falling towards, right? So that, take that logic, we need a new type of thing, and apply it to the question, why do all these things around us, which seemingly could have failed to exist, actually exist? Just take that previous argument, get rid of the word falling and supported, and think about existence, and run the same argument again. Making option one an infinite amount of stuff doesn't seem to help. It could have existed or not existed. Number two, a brute fact seems a bit like an ad hoc assumption there, although I'll come back to that one later. For the theist, it's option number three. We think that there is a kind of thing out there which exists necessarily, the reason for its existence is found in the kind of thing that it is. Now, you've got about a couple of thousand years of discussion amongst theologians about how exactly we explain this idea. Thomas Aquinas says that God is the principle of all being, or the source of existence. But whatever the case, God is not just another line on reality's shopping list. It's a different kind of thing. The point I want to make here is that to use this to illustrate the idea of God. If your idea of God isn't the sort of thing that could naturally bring an end to the question, and why does that exist, then it's not the idea of God that's been promoted by classical theism for the last couple of thousand years. And note that being supernatural isn't enough. Just being able to break the laws of nature isn't quite enough. The gods, small g, of ancient Greek could break the laws of nature, and they were which made them supernatural. But as far as the question, why does anything exist, they're like us. They're part of the problem. It makes perfect sense to ask, why does Zeus exist? But if you're asking the question, who made God, the God I'm talking about, that's a bit like asking what's supporting the core of the Earth. If you're thinking that way, you've misunderstood the thing being proposed, the idea being proposed. So these gods, small g, are just a bit more furniture laying around reality. They don't provide an ultimate explanation. They're just one more thing to explain. That's why Plato and Aristotle, even though they had the gods of ancient Greece at their disposal, still saw the need for an ultimate explanation, an unmoved mover, or the good with a capital G. Even some Hindu philosophers have spoken of a self-existent Brahman that is independent of space, time, and cause. Now, let me start to move towards fine-tuning, which is what brings us here tonight. When physicists propose a fundamental theory of nature, all the theories that have been proposed, they essentially come down to three basic elements. The first is, number one, the basic stuff of the universe and its properties. So you might think that the basic stuff of the universe is quarks and electrons. Number two is a law that describes how those properties change or interact or move, how those things do things. So, for instance, the law that says that protons are attracted to electrons. And three, the laws as we know them tell us how the universe changes. So if you want to say how the universe is, you need to know how it started off at any particular time. So in short, we'll call these 1, the stuff of the universe, 2, the equation that describes how the stuff changes, and 3, the initial conditions of the universe. So for Newton, the stuff was particles, the equation was F equals ma, and various other equations describing forces. And the initial conditions are just where everything is and where it's going at some particular time. We can do this for any theory. It's there for quantum field theory, it's there for Einstein's theory of general relativity, space-time, all of that. They all boil down to those 3 basic bits. So now let's just suppose that physics gets everything it ever wanted. Suppose that at some future meeting of the really important physicists, Einstein's great-great-great-granddaughter, Alberta, walks up to the blackboard. She does it nice and slowly because she knows she's got this. She writes down some equations and some diagrams, and fundamental physics is over. Right? Like some chess pieces who had worked out the rules of chess, we would simply understand at a fundamental level all the rules of our universe. Physics would be done. Everything would be on that board. You could ask deeper questions if you like, but physics will give you no answer. Right? So have that chalkboard firmly in your mind. If any of you know what's on it, please tell me. Right? But just stare at think about a chess piece staring at the rules of chess. So think about just staring at the ultimate rules of our universe. Like a completed jigsaw puzzle, we're done. So now what? Are our questions about the universe all answered? Well, I think there are some fairly obvious questions that remain. Stephen Hawking once asked, what is it that breathes fire into the equations and makes a universe for them to describe? The usual approach of science, of just constructing a mathematical model, cannot answer questions about why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? If one of the foundational postulates of every scientific theory is a list of the basic stuff that exists, then it can't tell you where that stuff came from. And if we reach the ultimate laws of nature, they will say what the ultimate stuff is. And if you want to know where it came from or why it's there, you're asking a question you will not get answered from that board or from physics at all. What I want to say here then is that if, like Hawking, you think that there's something to be explained beyond just what science can explain, if you see the world around us and wonder about the puzzle of existence, you will get exactly the same sensation by looking at the ultimate law of nature. If existence is the kind of thing that amazes you, then nothing on Alberta's board is going to solve your problems. So if we're going to explain this, we need something else. And that's the point of my argument here. Let me put this another way. If there's no God, it's not because we found a natural replacement. It's because theism tried to explain something that didn't actually need an explanation. Now, if you're going to reach that board and, like materialism, say that this is the end of all explanation, then you'd seem to leave an awful lot unexplained. You will leave the ultimate question of existence unexplained. Why is it that anything at all exists? Now, lean in for a really deep revelation here, but the thing about existence is it's all over the place, right? It's everywhere. Everywhere you look, there's stuff that's existing, right? Stephen Wright once said, it's a small world, but I wouldn't want to have to paint it. If you've missed out explaining why existence, you've missed an awful lot. Now, perhaps all of this existence stuff is a bit abstract. So I want to have another go at, we're standing there staring at Alberta's board. What else can we say about it? In science, what we want from our theories is that they be informative. This is a technical term, actually. A really informative theory is one that can look at a large set of possibilities and pick out the one that actually is. A non-informative theory is the opposite, one that leaves you at the mercy of a huge set of possibilities. Let me give an example. Suppose that a safe has been robbed. The security footage shows the robbers heading up to the safe. They pause at the button. They need to enter 12 digits, and they do it the first time, open the safe, take the stuff, and go. An informative theory will look at the set of possible codes, like there's a trillion of them, 10 to the power of 12. An informative theory will look at those and give us some clue about which one is more likely than the other ones. If you say that it was an inside job, suddenly of those trillion codes, one of them is much more likely, the one that gets you into the safe. If you have a non-informative theory, like he just walked up and guessed, you're still at the mercy of those trillion different possibilities. So let's have a go at that chalkboard again. Are there any other ways that the physical world could have been? Any other possibilities other than Alberta's chalkboard? Yes, all of mathematics. If you're a materialist, the only thing that can constrain what's on Alberta's blackboard is internal consistency. There is, by definition, by hypothesis, no other principles that govern reality. This is one of the reasons why I'm a theoretical astrophysicist. One of the reasons why theoretical physics is so hard is because there are so many possibilities. You can't just sit down on your armchair and have a go. You can come up with all sorts of equations. Every equation could be a possible universe. You actually have to get out there and look at it to find out which one is ours. So think of Alberta's blackboard and put it on the wall. And then on every other scrap of the wall of whatever huge room we happen to be in, fill that with every other mathematical equation, every other way the universe could have been other than Alberta's way. You have every mathematical library at your disposal to do this. If you are now wondering why that blackboard of stuff, why is that the one that describes reality, you will not get an answer from the board. There is no mathematical equation that says, I'm the one that describes reality. There is no equation that is so pushy that says, I'm so awesome, the universe has to conform to me. What that tells you is that the materialist gets to the ultimate laws of nature, faces up to every single possible way the universe could have been, and has nothing to say. It is at the mercy of every possible way that physical reality could have been. It is possibly the worst non-informative theory I can think of. Theism faces Alberta's board and keeps looking for an explanation, for a deeper reason. On theism, we look for a deeper reason for the universe. If you want to understand the actions of a person, you try to understand their motivation. God, by hypothesis, is good. We can understand God's actions in terms of things that are morally good. Why this physical stuff? Because it does something morally good, morally valuable. Theologians have for a few millennia argued that love is by its nature self-giving, other person-centric. So to create an object of love who will be loved and will give love is a good thing. It's a good reason, for example, for a couple to have a baby. But why physical stuff? Well, here's a rough idea. It creates the conditions for finite beings to interact with each other in morally meaningful ways, including love. There are actions and consequences, and those consequences play out in a public and predictable environment we call the physical universe. How much of an advantage is this? We need an informative theory to narrow down the set of possibilities, and here's where fine-tuning comes in. We don't have the ultimate laws of nature, so the best I propose that we can do is to take the deepest laws that we have and to find amongst them a set of possibilities that we can accurately characterize and systematically look through. What I would suggest is we should take the ultimate laws of nature as we know them and vary the free parameters in those laws. So, for example, they don't tell us how heavy an electron is, how strong the fundamental forces are, how the universe started off, the value of the cosmological constant. As a proxy for attacking this question, we can take those laws and change those numbers. This gives us a set of possibilities which is not biased towards finding life, because we started from our universe and got the search from there outwards. That biases you in favor of finding life, if anything. That I propose to be the test. So what has happened over the last 40 years is that physicists have discovered that the necessary conditions for life are extremely rare among the set of possible universes. This was not invented by theists, but discovered by physicists. It appeared in the scientific literature before it was in any theological book. Here are two quick examples. Einstein's cosmological constant causes the expansion of the universe to accelerate. Our equations dictate the possible range of the cosmological constant from what's called plus or minus the Planck density. Actually, there are good reasons to think that the Planck scale is the cosmological constant's natural scale. Within this range, we can quite safely find a subset outside of which life will not form. If the cosmological constant on this scale is either too negative or too positive, within a factor of 1 to the power in 10 to the 90 of the total range, you either get a universe that collapses into nothing in about a second, or expands so fast that no structure forms after about a second. Every single proton in that universe is doomed to spend its life alone in empty space, with every other proton out beyond an event horizon. It will never see anything else. That's a pretty dead universe. Alternatively, we can change the values of the fundamental particles. It doesn't take too much relative to the Planck scale, which again gives us the upper limit, about 1 part in 10 to the 17, gives us a universe in which things don't stick to anything else. The most you get are 2 particles that collide. You can't get anything like the complexity we need for life. Examples could be multiplied. Please read the book. My co-author, Geraint, is an atheist. So the science of this book really isn't that much in doubt. In June, I'll be at an international conference called the International Conference on the Physics of Fine-Tuning, run by a group at Oxford University. Fine-tuning is how we test theories. What I'm saying is that if we think hard about what science can and can't explain and what a good explanation is, we'll see that when physics is done and dusted, theism will have a major explanatory advantage over materialism. Starting at Alberta's blackboard and keeping our eye on all the other possible blackboards of ways that the universe could be, materialism must convince you not to look for deeper reasons. But I want to suggest that the time to stop thinking is not when you have such enormous questions left unanswered as why does anything at all exist? The time to stop thinking is not when you still don't know when science works at all. Why is there a physical universe? Why does it obey laws? Why is it there at all? And especially, the time to stop thinking is not when you are faced with the enormous set of possibilities represented by every mathematical equation we've ever seen. That is not the time to stop. That is most certainly the time to keep going and looking for a deeper answer. It is an answer that theism says is that a good creator made our universe for a morally good purpose. And I want to suggest that it explains an awful lot of the world we see around us and the universe discovered by science. Thank you very much.
Our second speaker, Dr. Matthew Titsworth, is a mathematical physicist who studies algebraic and topological models for particles in two-dimensional physics. He received his MS and PhD from University of Texas at Dallas and 2 BS degrees from the University of Louisiana at Lafayette. His sweet mom is right back there, smiling and grinning. She is a student at Bright Divinity Seminary. I want you to know she's not responsible for him being an atheist. She's very sweet. Speaking also tonight on the topic of materialism and theism, do fine-tuning arguments succeed? Please welcome Dr. Matthew Titsworth.
Good. All right. So, cool. That was fun. On my end, I generally take as the starting point, the sort of pithy way to describe my worldview. I take this from Hamlet in Act 1, Scene 5. This is the scene where Hamlet and Horatio are standing out in the bitter cold, waiting for the ghost of Hamlet's father to show up. And Horatio in this was really Shakespeare's representation of the rationalist mind at the time. People who went out and were thinking and destroying the hegemony and the ideas that had existed at the time. And as they're standing there out in the cold and Horatio is being skeptical, Hamlet looks to him and says, "There are more things in heaven and earth, Horatio, than are dreamt of in your philosophies." And I love this quote because I find that these days, in my view, well, we've managed to turn this on its head. So many things that we thought had, there we go. So in the intervening 400 years, we've learned a lot, and I find, so we've discovered more than we ever thought possible, and we found out so many things that we thought had no basis in reality. So as a scientist, I find that I have a responsibility to keep this constantly in my mind and to guard against false or unnecessary beliefs, no matter how comforting they may be. For eons, humans had kind of looked at the heavens and imagined answers to questions they could not yet understand. For eons, humankind turned out to be entirely wrong. So, for me, this is exemplified by an exchange from The Lion King. So I would imagine many of you have already seen that. And there's the scene where Timon and Pumbaa and Simba are all sitting there under the stars, and Pumbaa looks and he says, "Hey, Timon, so ever wonder what those sparkly dots are up there in the sky?" Pumbaa, "I don't wonder, I know." "Oh, what are they?" "They're fireflies. Fireflies that got stuck up there in that big bluish black thing." "Oh, I always thought they were balls of gas burning billions of miles away." "Pumbaa, with you, everything is gas." Throughout human history, many things have been gas. Aristotle posited that the natural state of an object was to be at rest. And in 1638, Galileo published new work which demonstrated that this wasn't the case. So he showed that an object in motion will tend to stay in motion. And up until the 19th century, it was believed that living organisms are fundamentally different from non-living entities because they contain some non-physical element or are governed by different principles than are inanimate things. Only something living with this non-physical element could create organic compounds. However, in 1828, Friedrich Wöhler discovered a process by which one could convert ammonium cyanide into urea, something that we're all familiar with whenever we hear the call of nature. At the same time, in our studies of science, we've come across unexpected discoveries that fundamentally change what we know about the universe. Physics began to break down at the end of the 19th century, so much so that in the 20th century, we had to start inventing new ones. A major piece of this was quantum mechanics, which governs the behavior of particles at the smallest scale. It turns out that at a very smallest scale, you can take two particles, tie them together, shoot them off in opposite directions, and they will still be able to communicate instantaneously, i.e. faster than the speed of light. This is called entanglement, and like the laser and the silicon transistor, it will transform the world that we live in. A priori, we had no reason to believe that entanglement should exist. In fact, entanglement began as a paradox put forth to refute quantum mechanics. Its authors, chief among them Albert Einstein, couldn't believe that such a thing could be true, and yet to the best of our knowledge, it is. Given this, I generally find the following to be rather convincing. 1, giving observable phenomenon, as time goes on, we consistently find perfectly reasonable, however initially counterintuitive, physical explanations for why they occur. Number 2, over and over again, whenever human had posited some non-physical or supernatural or sort of dualist explanation for explaining what exists or any of these things, we end up being wrong. As such, when I am faced with the hoofbeats of an impending mystery about the universe, I am inclined to think of the physical horse rather than the ethereal zebra. Now, just like everybody else, I'm fascinated by the question of why. Indeed, the question of why our universe is the way it is tantalizing. This is the whole reason for becoming a mathematician and physicist. But what these things have taught me is that we must be careful in trying to address such questions. I can't speak for anyone else, but I personally consider the following things to be rather important to being able to construct a worldview capable of addressing big questions. So the first of these is falsifiability, and this is a cornerstone of 20th century philosophy of science. And it basically boils down to whatever explanation I come up with, I have to be able to be proven wrong. Specifically, it requires that I come up with something testable, and to be testable means that if I make a claim, there has to be a way to show that claim to be false. The second thing is minimalism. Whatever explanation I come up with, it should make as few assumptions and require as few moving parts as possible. So if I need to expand on this for any reason, I should have a damn good empirical justification for why. This is essentially the content of Occam's razor. All things being equal, I should prefer the simplest explanation. Now that all things being equal is of a tremendous importance. If a more complicated explanation correctly describes something a simple explanation doesn't, then I should abandon the simple explanation because that simple explanation will have already been falsified. And so the third thing that I find that I need in order to do this is I need predictive rather than descriptive ideas. Whatever explanation I come up with, I want to be able to learn something new from it. My parents were very fond of the "because I said so" line of explaining things when I was a child, and that never sat well with me. So where do we begin if we want to systematically understand the nature and structure of the universe? In my case, I'm interested in observable and reproducible phenomena, and the easiest of which to consider at this point are physical, which is to say that those phenomena which can be described by a physical theory. As far as I know, we're not here to debate whether or not the physical part of the universe exists, so we can take this as assumed. In this case, then, given that at least something physical exists, a natural and minimal assumption is simply that everything is physical. So, to quote Tom Robbins from Villa Incognito, "It is what it is, you are what you it, there are no mistakes." The position that everything physical is known straightforwardly as physicalism. To be less pithy, a real statement of a position should be that all observable phenomena are physical phenomena, which is to say that they can be described by some physical theory. So I've used this term physical theory twice now, so let me clarify what I mean by this. A physical theory is a mathematical model which, within the confines of its definition, correctly predicts the behavior of one or more physical phenomena. Luckily for me, the criteria I've set forth pretty perfectly match the methodological outline of how one might want to go about creating physical theories for observable phenomena. So, my personal favorite example of this lies in the death of the luminiferous ether. So, ether has been around for millennia. It was posited back by Plato, at least as far as I could find in looking this up, in some sense or form. And it's presumed to be the medium, it was presumed to be the medium which filled all of space. In the 19th century, a guy named Maxwell, whose solutions to equations showed that the constant speed of propagation for electromagnetic waves was the speed of light. So, to serve as the carrier for these waves, Maxwell invoked the idea of the ether. But unfortunately for Maxwell, an experiment came along which falsifies the existence of ether as formula. To this, various physicists, this experiment was called the Michelson-Morley Experiment. Huge, fundamental, everybody should know this experiment. Beautiful, wonderful. But Michelson and Morley falsified Maxwell, even though they were trying to prove him right. And to deal with this, various physicists thought to modify the ether. But as new observations came in and more modifications had to be made, moreover, all of these little ad hoc additions did nothing to account for their individual their intended observations. They were sterile with making respect to new predictions. What's worse was that this upstart young physicist, having some sort of annus mirabilis, put forth that observed phenomenon followed from the twin postulates that 1, all reference frames are equivalent, and 2, the rectilinear speed of light through a vacuum is the same in all reference frames. That young physicist, of course, was Albert Einstein, and this is his special theory of relativity. In this short anecdote, we see the hallmarks of all three guideposts. However, there's yet another wrinkle to be considered in how I look at these things, and that comes from the fact that I am also a mathematician. Specifically, I'm one of those bastards who both sides consistently disowns. Mathematicians say I'm a physicist, physicists say I'm a mathematician. It makes it really hard when I go to conferences because I have to sit at a table alone by myself in between both sides. It's like being back in high school again. But in my role as a mathematical physicist, it is my job to take those physical theories and put them on firm mathematical footing. What this does is allow us to make new predictions about potentially new phenomena by better understanding what must be true about what we already use to describe current phenomena. Luckily for me, this program was already in existence by the time I got here. It's called Hilbert's sixth. It falls under the moniker of Hilbert's sixth problem, and this is very important. But the reason for this little digression is as follows. In what I've just described, my goal ends up being to construct formal axiomatic systems whose statements correspond to descriptions of instances of observable phenomena. Now, it's a mouthful, and it's dry, and it's technical, but it serves a very important purpose. Namely, it paints me as Don Quixote tilting at windmills. So, I am forced to confront three fundamental truths at the exact same time. One, whatever axiomatization, i.e. mathematical description, I come up with, if everything I've done is consistent and makes sense, then there will be statements I can't prove. So, i.e. predictions I can't make. Two, whatever axiomatization I come up with, if I can prove every statement, i.e. if I can make every possible prediction, then what I've come up with necessarily contradicts it somewhere. And three, whatever axiomatization I come up with, it is only valid for the context in which it is defined. Well, so what's the big deal with this? Again, to be pithy, so if I've performed the above procedure correctly, I'm precluded from having a theory of everything. So there is no master equation I can write up on a chalkboard and be done with it all. There may be no light at the end of the tunnel because there may be no end to the tunnel. I am forced to accept the possibility of a never-ending, continuous excursion toward deeper and better explanations. And so that's kind of how I've approached this topic of fine-tuning. And this has been an interesting sort of thing because obviously cosmology is fun and we all like cosmology, and there's some really interesting stuff. And see, we agree. Physicists agree cosmology is fun and interesting. You should all know about it. So, and in going through the literature and trying to understand these things, what I found is, like Dr. Barnes says, fine-tuning is about, okay, we have these parameters for these models, and this is really, it's a very standard way to do things. But in going through, it seems to me that the key point in this notion is that the section of parameter space corresponding to where life can exist is small. Now, my particular area of mathematical physics is what's called topological quantum computing, and so small is really a game that I play a lot. So the short answer about the whole thing, as far as from a mathematical standpoint, is that the region which allows life to correspond to the life to exist corresponds to the intersection of some 7, 10 hyperplanes, some number of geometrical objects in essentially a 31-dimensional space. We project it down. The dimensionality is not the terribly important part here. But one of the things that comes out to me as a mathematician is, in fact, that this volume is finite. Because from a mathematical standpoint, that's an amazing thing. When we talk about how these things could have been arranged, I could pick at random any number of these different planes, and the volume that they enclose would be 0. And in fact, that's the most likely thing that's going to happen. And so the fact that I get this finite volume isn't of itself miraculous. However small that's going to end up being. So now, what this comes through in going through these things is that really, in order to be able to deal with these things, we need to define probability functions and other things like that, which involve doing these things like defining prior distributions and then the things that we condition them on. But again, it turns out that if you do this mathematical area of analysis and you study this thing called measure theory, this set of possibilities, even though there are infinitely many possible things within it, could still have had zero volume. And so the fact that like there are millions of different ways that I could get to this is sort of interesting. It's also interesting that I can get the dimensionality of this is not zero. It turns out there are lots and lots and lots and lots and lots of ways to do this. And what I would really have been intrigued by in going through and thinking that there was perhaps something wholly deeper about this is, in fact, like I said, if there were still infinitely many of these things, but they had no volume. And so as we move along, there's this whole idea of, well, we get to this fundamental theory in this blackboard. And as we move along, time and time again, we find that this idea of fundamental gives way to some new and underlying explanation that shows what our previous explanations were merely effective. So this all falls back to what a physical theory is. What this really means is that the validity of a model is context dependent. We find the limits of that context and we develop new models whose context is broader. So the whole idea of fine-tuning is predicated that what we know right now yields this seemingly weird result. But it could be that we simply don't know enough yet. The classical example is Newton's model of mechanics. In the realm where it's defined, it does remarkably well and it's understandable and stood unchallenged for basically 300 years. However, again, at the beginning of the 20th century, was simultaneously discovered that Newton's theory works within a certain band between high and low. It is, however, effective where it is supposed to be. There is an apocryphal quote which has been floated around physics for over a century now, commonly attributed to Lord Kelvin in a 1900 speech for the British Association that says, "There is nothing new to be discovered in physics now. All that remains in more and more precise measurement." And the irony of this statement was that almost literally after this happened, we discovered entirely new branches of physics. And so, to me, the theistic argument from fine-tuning, as presented, presumes two things. One, that Kelvin is eventually right, that there is a light at the end of the tunnel, that we can reach an end where there is nothing new to discover. So, two, that fine-tuning persists once we get there. So it presumes that should Alberta's blackboard exist, the issue will not have been properly addressed. This is where being a mathematician is helpful. In mathematics, we have to accept that there is no end. There is no single final mathematical construct in which all statements will be provable. Taking a cue from this, I personally find it doubtful that we will ever even find a theory of everything. Once we find a theory of everything, chances are there will be a new theory to try and get, and that this will, again, still be a totally physical theory. The name theory of everything is misleading. So this isn't to say that our knowledge is useless and we should despair. But our ability to use that knowledge is context dependent. We should not assume that it is of value when we step outside the appropriate realm. So the theistic argument from fine-tuning is predicated upon assumptions about what we may know in the future. It assumes that when we see the blackboard and all of its fine-tuning and glory, the basic and the irresistible, so basic and irreducible with a non-zero probability of chance, what do we learn then? How do we figure out the last great mystery? And this is the place I start from, is my minimalism. Whatever the answer is, Occam's razor is a good guide. So the question then is whether or not, so we want to find an explanation where all things are equal. And then the question is whether or not all things are equal. And quite frankly, from what we have, given all things are equal, if we presume what we can observe from now, that everything is physical, so the unfortunate simplest explanation is that chance. So it's totally unsatisfying, and it is, maybe wrong. It's likely wrong. It's probably that we need something further down, given what we know. But as it stands, that's the simplest explanation, at least however unlikely it may appear at the moment. And so to create an answer to this and to find some way things are not equal, the theistic position presupposes the existence of a thing beyond the physical, that there must be something that can't be explained on physical grounds. And then theism answers this question by, then theism answers a question by presuming an answer. So, well, let's presume there is something else. Now we have something new to explain, and this really sort of begs the question. So, this whole thing irks me not only because it is unfalsifiable, but it has to add a whole new moving part whose whole purpose is to serve it as an impetus for constructing itself. But I also fail to see what new information it provides. Beyond the truth that theism is a better explanation because it is assumed true, what else does fine-tuning from theism give me? And as far as presented, theism is a descriptive answer to the question rather than a predictive one. So we can presume that God is good and that this is why good is in the world, but then we have to assume that good exists in the first place. All we end up doing is adding more and more and more assumptions on top of this. If I have to do this, it also doesn't tell me anything new about what I already know. Physics and the physical universe are, as presented, work just as well with or without it. So, and we know, to wrap up and conclude here, we know much more now than we did 100 years ago, and we can use that knowledge to do wonderful things. We know so much more about how much bigger the universe is now than we've conceived of to begin with. This is a scary thing, so begin with. Moreover, with everything we've ever learned, there is no reason, as far as I can see, to assume that there will ever be a limit to how far we can go with this. This is a scary thing, and I wrestled with its implications for a long time. So, for a long time, I found it easier to assume that, as Hunter Thompson put it, that somebody, or at least some force, is tending the light at the end of the tunnel. But where does this leave this? If we can't get to the end and ask the question, what will we have learned? Simply that there are more things in heaven and earth, Horatio, than are dreamt of in your philosophies.
Dr. Matthew Titsworth. If we could put both chairs at the table, we'll do cross-examination. Both presenters will have 15 minutes to ask questions of the other. I will only announce the 5-minute and 2-minute mark. Would either of you like to go first?
I'm indifferent.
We put it to a vote.
All right. 15 minutes. Let's go.
I'll go. All right.
Okay.
Good. Excellent. So there's a sort of sarcastic version of one of your arguments that I want you to tell me is why this is not what you're saying. But I find this in a lot of Lawrence Krauss types. The argument goes like this: we used to believe X, and we used to believe Y, and we were wrong about Y, therefore we're wrong about X. And the way you apply this is, we used to think Aristotle was right about this, and we used to think there was a God, but we don't think Aristotle was right, so there's no God. How is your argument avoiding that sarcastic summary?
So I find that really sort of misrepresents things. My argument is that we used to think many things that were wrong, and so why should we assume that this thing is, let me say this correctly. It is not to say that it is necessarily wrong, but to say that we cannot presume that it is right. If we move forward as we get this new information, why should we trust that our oldest ideas will still be the best one? So if we've had these ideas that are around for thousands of years, the firmament, the ether, all of these things that came up at the same time, that there has to be an unmovable object at the same thing, all the other things that get knocked down around there sort of keep getting knocked down. And so it's not to say, it is not a position that it is wrong. That can't be made as a logical conclusion.
Mm-hmm.
So, but it is to say that it calls for skepticism of old ideas. So
Okay. So if my argument had been you should be a theist because theist was here first, that would be your reply to that.
If your argument was that you should be a theist because theism was here first, my argument wouldn't really change. I mean, so it's not, theism is a very, very old idea, and what new evidence have we been presented for its existence?
Right, okay. Your third point about predictive rather than descriptive ideas, that seems to leave rationality beholden to certain accidents of history. If we happen to find out an idea before we find a certain piece of evidence, then that, or the other way around, we're just beholden to that, particular state of affairs. So if we, what's an example? So you get my idea. So if we find the evidence first and then comes along the theory to explain it, even if it's the right one, it's only descriptive. No, so it gets punished for that.
Well, it's not true at all. So the ether is the example of that. So special relativity made all sorts of new predictions that were, so when special relativity as an explanation for the Michelson-Morley experiment came out, it suddenly made all sorts of new predictions that went along with that. So to be predictive, you have to be able to see what we know and then put something new with it.
Is the Michelson-Morley experiment evidence for special relativity?
So the Michelson-Morley experiment falsified the luminiferous ether. So special relativity was not falsified by Michelson-Morley and made new predictions which were themselves new things to be added on top of it. Whereas Lorentz's ether theory and the luminiferous ether as it went along failed to make any new predictions about things.
Okay. What do I want to get at here? So there's a very interesting little argument in the middle there about whenever you have a set of axioms, there's always things you can't prove in those axioms. Mm-hmm. But Gödel's theory only applies to piano arithmetic.
Gödel's theorem.
Have we bored everyone yet? Do we need to explain what Gödel's theorem is?
So if you go to the original German paper, Gödel's theory, Gödel goes ahead and proves this. He says at the very beginning, I'm going to do this for piano arithmetic because it's very easy to do. But his definition of a formal axiomatic system, and the specific reason for using that phrase, is much broader than simply piano arithmetic.
We're not going to decide that up here. I disagree, but never mind. But there still seems to be how do you want to say this? There still seems to be an equivocation here between some particular mathematical theory that has to have all these predictions and then a physical theory. So that's not going to work. If there were mathematical theories that are free of contradiction, which I thought there were.
Euclidean, so classical geometry, for one.
So all that would say is that if there is an ultimate theory, then it would have to rely only on those concepts. You have to stick within theories that don't end up contradicting themselves.
So you would have to stick with a theory that's not complex enough to do the things that we see.
Well, we don't know that yet, right? There could be consistent theories we haven't thought of. Mathematical axioms.
So any theory which presumes addition in the natural numbers is going to be too complex.
Sure. Okay, but is reality itself free from contradiction?
So
let me just put that as a syllogism. Reality itself is free from contradiction. Reality can be described mathematically, so there must be some mathematically consistent description of the physical world. It must escape Gödel somehow, but don't ask me, I'm an astronomer. Over to you, mathematician. Sorry.
I don't think we can know whether or not reality itself is consistent. This is not a question that is really answerable. Ooh. What we do is we construct models of reality. This is what our physical theories are. They are ways of explaining things. And we cannot construct a consistent theory that will ever be able to explain everything. There will always be another theory to build on top of it and to be able to find new things for.
If materialism is true and there's only physical stuff, why couldn't there be a materialistic universe in which Newton's theory is correct? There are just point particles, they interact via gravity, F equals ma, that's the whole story of the universe, and let's assume that for the moment it's mathematically consistent. Why must there always be an infinite regression? Why can't that be a materialistic universe?
That's a good drink move, by the way, on thinking about this.
I am. Do you want to come back to that?
I mean, if there was... Why couldn't that be a materialistic universe?
We can come back to that. I should say, like, you know, we're on a stage with lights pointing at us. This isn't the greatest environment to think about stuff. We're all, but yeah, the fact that we can't think of something right here, right now doesn't really mean so. We're fine. But I just won. No, it's okay. Sorry. No, email me with a good answer tomorrow. I don't mind. So the point is,
I mean, I don't even know why. So why it can't be? I mean, Newton's theory is in and of itself not complete. So it works well in the context in which it's defined, but it is still not perfect.
That's not a problem with its. That was a question for the other way around. Whatever. I'll try and phrase this as a question because I'm supposed to be asking the question. I would say that it's not a complete description of this particular world. But the question is whether it's a possible materialistic universe. See, your point was that we can never be at the point where we're facing Alberta's blackboard, right? Because there's always something else. Well, I said, well, just put Newton's equations on a blackboard. That's a possible world, and by hypothesis, there's nothing deeper about the physical world. There's no infinite regress of theories below it.
Well, so then I think you have misrepresented what I've said. I've said we have no reason to believe that there is an end. So, which is not to suppose that there is no end.
Okay,
but to remain skeptical of this seems well-founded.
Okay, the Gödel point seemed to be going for a lot more than that, that it is actually, from Gödel, impossible for there to be an end. That's not what you're saying?
So, I am saying... I am saying that if you wanted to formally axiomatize Newton's theory in the appropriate sense of Newtonian mechanics, whatever theory you came up with would not be able to explain everything in that materialistic world. Newton's theory is an effective theory. All of our theories are effective theories. So what you want to do is you want to suppose the existence of a material world that is completely described, where all of the statements are determinable from this. But this, by its assumption, would then assume that there is something within that world which is self-contradictory. And so you want to presume a world, but you want to presume a world that contradicts itself.
Okay. I think my point is I'm trying to think about materialism. If materialism is true, then the physical stuff is the only stuff. So there is some, at least, the chalkboard example is just trying to sort of, let's try and think about the idea that physical stuff is the only stuff, in which case there is just a set of physical facts and that's the end of it, right? So problems of mathematics and axioms and all of that, we're in danger of sort of missing the point here, that even if you had all of the infinite axioms, if you needed an infinite number of axioms to describe the universe, or just write down all the physical facts on a board, you would still have a lot of other ways that the universe could have been. Don't do it via maths. Try and do it via just an infinite number of axioms or something.
Well,
like that.
I can. If I don't do it via maths, I'm not being systematic anymore. If I'm not being systematic in my thinking, I can get to whatever I want to.
But there is. Okay, we could still do this with an effective theory. Let me try and redo this again. Suppose what's on the board is just the best effective theory we'll ever get. All right, and reality is whatever stuff we need to make the world out of, so that that is the best effective theory.
Statement. Best effective theory implies that there should be some way to create a better theory.
Yeah, fine, but at
any given point, so you can look at things and go, these things don't seem to fit well within the current description. So, but to presume that there's an end is different from saying, given what we know now. And this is a big assumption that there is an end to the whole thing.
But if you're a materialist, there is, I mean, physical facts are the only facts. There is, you could do the philosophical thing of just take all the physical facts and combine them into one gigantic statement and make that what the universe is like. It wouldn't fit on a chalkboard. And the hope of physics is that there will be some equation which describes or whatever all of those facts. Rock on. So either way, we're facing the same problem. Why is the universe the way it is? Can I run the argument that way, or does that still run into the problems you see?
2 minutes.
I mean, yes, I think it still runs into the problem, but this gets to my second point, which is presume that we get to a blackboard. Why should fine-tuning, why should these problems, if we get to that blackboard, why should these problems still exist? That sort of comes up with, that contradicts the notion of getting to the blackboard in the first place. So if I were to get to a blackboard, I would presume that it would have an answer to this somehow.
But that's exactly the point I'm making. If you're a materialist, then you get to some brute facts at the end, and that's all there is to it. You could be staring at a blackboard with fine-tuned laws on it, or that is fine-tuned
the notion of your blackboard.
No, or which is fine-tuned with respect to all the other possibilities of the way the universe could have been, which is the important one. It might not be fine-tuned in its own skin, so to speak, but you've still got an open question. Why this universe rather than the others? Should we expect some sort of answer for that somehow from the board?
So I was going to bring this up to you. So we can, if you want, we can.
We can just stall for a minute and a half.
Well, no, we're not. We don't need to stall, but I think we can just sort of move straight through because this is my question to you.
40 seconds.
40 seconds.
All right. So I'm gonna talk for about like 30 seconds here and not blow off your answer. No, not at all. And so the question becomes to me. Now I've lost what your question was, and that was not actually meant to stall. I just like it has fallen out of my head. Yes.
Does anyone remember what my question was?
Your question was, why fine-tuned versus other possible universes?
So yeah, well, is there any reason why the universe is the way it is rather than all the other possibilities?
Right. And so my thing is that a meaningful question? So is that a question that we can have some sort of knowable answer about without having to assume essentially that we have an answer to it? So I mean, so there's this notion between between questions that we can form linguistically using the phrasing of a question,
right,
and things to which we can assign a knowable truth value.
Right.
And the question, and so the thing I pose to you now is that how do we suppose that we are able to know the truth value to this statement? So as I understand, the theistic, you have to assume that there is no way to understand this. And by having to add that assumption, you've already stepped outside of what the original question was.
So, I mean, let's just take the point about, are we just sort of presuming an answer? If you want to say that, all physical theories just presume an answer, right? So take the example of the burglar. If you just presume that there's a burglar who knew the code, then you can explain why they entered the code the first time. The point is,
in that case, I'm sorry.
So the point is that, given what will explain what we know about the world, I mean, the whole point of a theory is that it's not just the data, it goes beyond the data. And so you can say in some sense that all theories must presume something. The point is to then go and test them. What will they explain about the world?
Right, and so what is testable about the theistic position? With respect to the burglar, I can have observed the burglar. I can have the burglar on camera. There is a way that I can observe,
right,
and see that the burglar was there.
Right.
So what is the falsifiable, what is the testable position? What is the testable part of this? What could not be true without a God?
So I think there are, I think it's goodness that gives you the ways of testing.
So what is good?
So,
see, this is the thing, is
people
that you
know
have
the
to
context of that particular question. Oh no, what is truth is the other one, sorry. Just to say, a lot of people think that the existence of evil in our universe is the way of testing this idea that there's a good creator and showing that it's wrong. Now, that's a thing to have, but if there is a good creator of the universe, we would expect the universe to have positive moral value. That is something that we can, the fact that we knew about it already makes it dangerous that it could be an ad hoc assumption, but sometimes we learn about the data, the order in which we learn the data and the theory are just a historical accident. So, do you want me to answer the what is goodness question?
Absolutely.
All I need for my argument, I think, is that we have some moral knowledge. And really the thing that I relied on was that love is good, and that'll do me. So I don't think, if we know anything about morality, we know that love is good, to the point where if you agree with that, then this shouldn't be a problem.
Well, and see, that is, I think, where the common disconnect occurs here. Because I can think of a person whose moral value, whose moral system is entirely opposite to anyone in this room. From a philosophical standpoint, which of these two is really the moral being? Which one has the real moral truth?
Right.
And so, yep.
I would say that the person who believes that torturing babies is good is wrong about a fact. And that's kind of all I need for this. There just needs to be moral. I mean, I can imagine a person who thinks that the sky is orange, but they're just wrong about that particular fact. If we know anything morally, then we know that love is good, and that's kind of all I need for my argument.
Well, and this is, I think this is sort of, I actually have a line here that we're going to veer off into common things that move away from our particular expertise on this, because this is a very old argument between theists and non-theists. What is good? How do you have moral asceticism versus moral relativism, and how do you assess the difference between these two? And I think I'm glad we got to this point, because if you don't mind, I'd like to go, let's leave this to the people who understand this and are experts in this particular subject. So, but it's just sort of a bound that I felt like the conversation is going to have to come to eventually.
I don't think I need to totally, you don't need to know everything about morals, you don't need to sort of solve it in some sense. But, so the crucial line in the argument is, what is the probability of a life-permitting universe given theism? And what I want to say is that if you think of God as a good creator, then that doesn't seem to be ridiculously low in the way that all the probabilities of a life-permitting universe given naturalism seem to be ridiculously low. So I don't think it needs us to totally know everything there is to know about morality, just that love is good and things that can love are good things to make.
Well, and again, it's like my problem with this is that theism seems to be the assumption, well, let us assume, to assume theism is to assume that probability is close to 1 to begin with. It really seems to beg the question. You seem to have come up with an explanation that defines that you're going to be right to begin with.
No. There are possible universes which, I mean, the point of this is that there are other possible universes we would expect God not to make. One with no moral value would be unlikely. One with negative moral value would be unlikely. We don't turn out to be in one of those universes. That seems to be in favor of the hypothesis.
Well, and so, okay, so let's keep it to this. How do we know that our universe doesn't have negative moral value? Why is a good God more likely than an evil God?
Okay, yeah, that's a good point. So this is a question of whether fine-tuning sort of outweighs the problem of evil. So there's a massive set of things you can look up about that. What I want to say is that I think that the evil we see around us, if we think about it, is sort of parasitic on the good. That death is an evil because I loved the person who was there to start with. If there were not the good of love, then death would not be an evil thing at all. So I think that evil is parasitic on good. So that leads me to suggest that think that the universe is, that there is, what do I say this? That good is the deeper thing, the deeper reality, and that it is the more important thing.
So then it's, so then it is good when, come up with an appropriate example to this. And that's just, so the thing of it is that, like that really sort of seems to be saying that all death is bad, and you know, because there are people who love, but there are. So there was this woman who was dying of a malignant brain tumor, and her life just truly began to suffer, and just became horrible. And her entire family fought for her to be able to end her own life. They felt that the better thing for her in that case was to be allowed to die and not to suffer. Okay. So, you know, this is, you know, even though you are loved and you are hurt by this, now death is a good thing, and there's an inherent contradiction here.
I don't see how that's a contradiction. Let me try and think through that. I think they can still see that the better state of affairs would be her to be alive and well. Right? That is what they would want for her. Even if you take the example given there that death would be better than prolonged agony in life, we still see that the evil state is a perversion of a good state. This is Augustine, right? Evil is the privation of good. If you don't have any such thing as good, there wouldn't be evil and good is like darkness and light. So it's still the case there that what is evil about that situation is that it is a good situation distorted and put out of proportion. That's a bit too weak.
Well, let's.
We are
like
miles
this
off
is.
topic.
I mean, so this is this is the big problem with, like, this is the. I think we've hit the big parts on the theistic versus materialist debate. Why does good exist? You know, where, you know,
oh, yeah.
what lacks in your universe if you're being materialist? Fist bumps for, you know, getting the big. Now let's be physicists again, because so I went through and I read your paper, the archive paper, several times, and I went back and I looked through some of your references, and now I just generally have some questions that get to be answered, and I think.
Thank goodness. Let's do some physics, dude.
Yeah, really.
Yeah.
We are not moral philosophers or doing anything. Let's stick to what we know.
We are moral. We're not moral philosophers.
So I read this paper. You know, the one by Tegmark and Wolkchik and all of these guys. And one of the things they're talking about is this notion of fixing priors and selection. So quick math. So part of this whole thing about fine tuning is what is the likelihood that we live in a good universe or in a good universe, in a life-giving universe. And there are some anthropic arguments that get used to try and figure this out. And this comes down to, if I'm not incorrect, using Bayes' rule to define prior probability. So the probability of having any particular universe to begin with, together with the probability that we observe this universe from various selection effects. And putting a bound on this prior really seems to be an important question, because there are two big ways that this could do, two opposite sides. So the far extreme on one end is that we have a delta function, which is to say that all of the probability exists in one place, and that probability is centered in the kind of universe that we have right now. If that were the prior, then the question of likelihood for other universes is essentially off the table. Mm-hmm. But on the other end, if this prior is uniform, then all of our observed oddity comes entirely from the selection effects, from the fact that we see what we are, and our observation of this unlikelihood is entirely a vagary of our perception.
Right. Yeah, we are heading towards some technicalities.
We are physicists.
Yeah,
it's impossible to get into a discussion.
They turned up, man. Here's what I'd say. The way that physicists use probability is that we think that they are what is called degrees of belief, or degrees of certainty. So it's not just a case that I'm thinking about frequencies of experiments. What I really want to know is, given the evidence that I have, how likely is a particular theory that I'm trying to look at? So when you're testing any theory, if it has a free parameter in it, you need to somehow sort of punish the theory for having that free parameter in some way or another, because it's given itself a bit of flexibility. The way that we do that is by noting that if all you knew was the theory, you wouldn't know what the free parameter was. Okay? What you need, so that's a statement where we want to assign a degree of belief. I know the theory is true. I know Newton's theory of gravity, suppose, but I don't know the value of the gravitational constant, the constant that goes in there. And so I need to represent that statement, I don't know, in terms of probability. That's what probabilities do. So if I throw a die on the floor, I don't know which number comes up, so I represent that by saying there's 6 possibilities. One of them is a 6. Probability of 6 coming up is 1 in 6. So what I'd say is that it is not the situation we're in. The two options there, the delta function, just to say I'm allowed to just assume one particular value that's in our universe, is the wrong answer, because it's not the state that we're in. If all I knew was the equation, I would not know what the free parameter was. That's why it's a free parameter. So what you then have is a broad range. What I want to say about the probabilities here is that the probabilities I need, I can get fairly straightforwardly from ordinary testing of physical theories. We need to test them in a way where we predict a certain outcome, and we need to know what the probability of that outcome is as a function of the free parameter. In order to do any of this testing, we have to the predictions that the theory makes has to take into account the fact that it introduced this free dial. All of those numbers are there in the theory when you predict the outcome of any experiment, and I can take those and apply them not to just any old data, but to the statement, this universe contains life, and that's what I'm basing the argument on.
And so you mentioned something about intervals of confidence. And this is an interesting thing that I sort of came across in trying to think about this, is because intervals of confidence vary from discipline to discipline. If you're in the social scientists, if you got a 95% confidence level on something, you're golden. Or if you're in biology, well, and we're in physics, and so we generally, require even more stringent levels of confidence. But the theistic assumption is that the level of confidence we have is such that we need to have something more. We need to add a totally new level to the universe. And if the confidence intervals that we choose are context dependent, how do you justify the assumption that even though our confidence with relation to other things is very high, how do you justify that it is high enough, that it is far enough away from zero in order to be able to make this jump?
So on the ordinary Bayesian thing, it's just going to depend on what you think the prior probability of naturalism and theism is. That's an issue that you sort of got to decide on other grounds. If any of that opening stuff I said about necessary being strikes you as remotely plausible, then it might have a high prior. If you think that that's an impossible thing and that a necessary being is even a logical impossibility, then you'll give it a low prior. How do we know? So remember what the point was. If you are at if your theory is at the mercy of a massive set of possibilities with no way to choose between them, then it's in a vulnerable state. Now the best way I can think of saying, all right, naturalism, all the ways the world could have been with an equation on a blackboard or not, represents one particular way out of a huge set of possibilities. The best way I can get a handle on those to try and test our ideas like naturalism and theism as we want to is to take the sort of theory testing we can do in physics and apply it to that regime. That is what I am proposing.
So, but that still doesn't...
Oh, I think we're
Last
done.
question. Go ahead.
Okay.
So that misses... I agree that it should be, we should subject this to theory testing, but getting to the, to the fine tuning, to the strength of the theistic argument comes down to choosing an appropriate confidence interval. And if we are to assume that you have made the case that this is an entirely new sort of question. How do we justify that confidence interval should be based upon the confidence interval we use for another kind of question, given that we already have this construct where constant confidence intervals are context dependent?
So I would say that what we're looking for is a kind of unbiased way of doing this, which is kind of hard when God is on the table. The best way I can think of doing that is to say, look, here's a problem in physics which is very close to what we've got.
But by definition, there are no problems close.
No, it is. On naturalism, there's nothing deeper than the laws of physics. So when I say in physics, given this theory, without knowing the free parameters, what's the probability of this outcome? That seems to me very analogous to, on naturalism, I know no reason for the universe to be this particular way rather than some other way. What's the probability of the particular universe we see? The best handle I can get on that second problem is the first one. And the fact that we can get those numbers, those degrees of belief, I would call them, from physics in that related context, but without having sort of one eye on the fine-tuning argument, that's just the way we test theories, is a good way to say, all right, this was not made up by me from scratch. Here is people just thinking, all right, let's just think about the theory inside itself.
But the reason for getting to this is, and I think I'm not totally against that, but then there's this requirement of necessity. And necessity is a huge condition. You can't you can't make the inductive to deductive link. This is the black swan fallacy. If all I've ever seen are white swans and all I think are likely are white swans,
as
then,
in that God is a necessary being.
Yes.
Yeah. Okay.
And so I don't see where you get from what confidence interval do you need in order to jump to necessity?
No, you don't prove a necessary being from the fine-tuning argument. So at best, it says that there is a good creator of the universe. If you want to know whether it's the necessary being from the cosmological argument or some other thing, you're just going to have to do a bit more thinking. So the way I would think about it is I think the cosmological argument I presented first, I think that works. But if you're confused by all the abstractness of that and the necessary this and blah, blah, that, let's just try and take that idea out for a test ride in some other region. Let's see if it will explain the fine-tuning of the universe for life. And I think it will, in a way that won't create who created the creator, who designed the designer, infinite regress. We can cut that off for the same reason we can cut off the questions of existence and just go straight back to a necessary being. I see that as a simple explanation.
Thank you both. Dr. Luke Barnes, Dr. Matthew Titsworth. As a reminder, the topic of tonight's debate is materialism and theism. Do fine-tuning arguments succeed? And Q&A is a continuation of that. This is where we invite you to offer your challenges to what's been shared. Your question, everyone say your question, should be no longer than how much, Dr. Zach?
Let's say 60 seconds.
Woo! I offer 2 minutes. He's a quick man. 2 minutes at maximum on your question, please. Please keep your question germane to tonight's topic, which thus far is pretty widespread. You know, I was told once that I use big words as a weapon. Tonight, that would be considered a blitzkrieg. So, this microphone is for questions to Dr. Luke. That microphone, questions to Dr. Matthew. We will start over here, BBC alumni, Dr. Zach.
Dr. Barnes, thanks so much for your presentation tonight. I would, if I could, as the biologist in the room, or one of the biologists in the room potentially, attempt to shepherd the physicists on stage back into the realm of moral philosophy, because I found that really fascinating. And in particular, the question about a good creator and what a universe might look like if it was created by a good creator versus an evil creator. And I'm really curious, presumably your argument is that the universe was created by a good creator, but I'm curious to see what the alternative might have been, what can you give us in terms of a possible explanation as to what a universe would look like if it had been created by an evil creator, potentially to advance some ultimate evil aim that's beyond what we currently know?
Okay, am I on?
Yes.
Yes, good. So I've often joked to audiences that fine-tuning gives you some really great ideas if you're a super villain about how to destroy the universe. So let me just indulge those for a bit. I think we understand what an evil state of affairs might be. So a universe in which every agent in it experienced only pain and torture for their entire lives, and with no reason for it, nothing that sort of redeemed it in the end, nothing that sort of balanced the other side of the scale. I'd come back to the point I made before, though, that if you really want, you have to have good before you can then distort it and get evil. So, if you really want to hurt someone, you have to build those loving relationships first and then break them. So what would an evil universe would seem to need to have, would have to take a good state of affairs and then break it. But you can imagine your own particular evil universes, so endless torture without relief and without reason. So the point about this universe, the basic answer to the problem of evil is Augustine's that I have, is just that God saw that it was better to allow some evil for a time rather than no evil at all. I mean, we can argue about whether you find that plausible, but that's my position.
All right, fair enough. Thank you so much.
Cheers.
Can I say something about that real fast?
Yeah, we should do that.
So the whole reason that came up is sort of serendipitously, Aeon Magazine recently published a video that asks that exact question. So about the presumption of an evil god versus a good one. So there's a video if you go Google it. It's pretty interesting. Yeah. I will.
You, Dr. Matthew, I never heard whether you believed that the universe is fine-tuned. Is that yes or no?
So the advantage I have is that I get to be just skeptical. So as a mathematician and a physicist, there's this side of me that says I don't know is an okay answer. We were talking up here, one of the things about mathematics is there's this thing called set theory, and there's this thing called the axiom of choice. And you can't use one to get the other. And there's this big debate over and over again as well, are you going to use the axiom of choice or not? And there are basically three positions. There are people who go, yes, I'm going to take the axiom of choice and run with it and do all of these things. And there are other guys like, no, I don't want to add that into my world. I'm gonna go work over here without it. And then there are the people who are like, meh, I'm going to do what I'm going to do, and I'll see if I ever need it as I go along. And that really, that's my example for how I come to the whole thing, is I don't feel like I have enough information. I don't feel like we are far enough down, close enough to a fundamental theory to be able to say whether the universe is fine-tuned.
Or at least given some of what we know, like Dr. Barnes issued some of the technical points, like the cosmological constant and the weak force and the strong force and all those kinds of things. I mean, do you agree that those are at least there, right?
Oh, I agree that particle physics tells us a lot, and that we know a lot about inflation and cosmology and these things.
So if so, then the traditional explanations of the fine-tuning have been three: either physical necessity, chance, or design. You're against design, correct?
So that would leave on the whole thing. So, like that's.
If you had to choose, which one would you come down on?
None. I don't choose. I
Just
don't have to choose. I am free of having to make that decision. It's not a question I think I can know the answer to, and so I want to focus on other questions.
Okay.
Do you want me to respond to? So fine-tuning within physics is within that very narrow sense of here are the laws we have, change the constants relative to the possible range, is life a small region? That's fairly well established. I don't think we're worried about that.
There's no.
So what follows from it is the million-dollar question. God.
Okay. I'd like to ask a question to both sides, but I might have to jump to the other side of the mic, I guess. I don't know. We'll see what we do.
Go for it.
But first,
Stand in the middle.
sure. I'm a Christian. I'm a friend of Matthew here, so I feel I have to be very level here in my questions. So. But I'd like to bring us back to physics, if that's cool. And Luke, actually, I'll give you your blackboard, okay? I'll give you the blackboard here.
Cool.
It's been tough to get to the blackboard or whatnot. But here's a trick. So where this fine-tuning game comes from, if I can post it out real quick, is so from what we know, we can write the equations that we know on this board right now, right? And when we get to the end of it, there's certain numbers. There's just numbers that are there.
Yeah.
We can measure the numbers. But we can't really, there's no more laws. There's no more reduction that we can do. We get to these numbers, and for some of these that you've looked at, maybe 10 or so, if you tweak them a little bit and they're off, then we don't get life. That's the game. That's the game that we're playing. Yeah. To me, I've got this kind of question. I don't know what to do. It's the actual game of playing this fine-tuning argument. Is this not a sort of philosophy in and of itself in terms of isn't this not the same sort of game like playing the multiverse theory or whatnot? Are we not stepping into the same sort of bounds in terms of are we not going to the same level of speculation as we would for that? And we clearly dismiss that because we can't observe those things. We don't live in a reality where we can physically change those parameters. Mm-hmm. Are we not slipping into a philosophy that's the same as, let's say, multiverse theory or whatnot?
So my answer to that is the reason why physicists said, what would happen if I changed the constants, is because we need to do that to test any physical theory with free parameters. Even to infer what the values of those parameters are from observation, we need
string theory. Oh, excuse me.
Oh, come on, man. String theory? No. So I'll deal with that. The cough, I mean. No. So we need to do that in any theory with free parameters in it. So the whole question of what would the universe be like if this particular equation with these numbers in it were the way the universe was is just theoretical physics. That's what we do every day. That's what you have to do. So I don't see that aspect of it as speculative. In particular, I find some people say, you know, how can you possibly know what would happen in those other universes? If we can't answer that, we can't do theoretical physics, ever. In particular, it might be the case we get a deeper theory with no free parameters in it. String theory is an example. What we discovered in 2003, Susskind, was that actually all of the... There was no... Here's the equation. Remember the equation? Number 2 in my list of things. There are no free numbers in that equation, but there's now a huge set of initial conditions. So all the numbers like the mass of the electron and the cosmological constant, all of those things are still there free in the theory. They're just in the solutions, not in the equation itself.
So I agree that being able to play this game includes some philosophy of its own, and this is actually a question in philosophy of mathematics as to whether or not we can play these games determines what really is predicated on whether or not you think, for getting down to it, whether or not you think some triangles existed when there were dinosaurs. And this is to say that there's this idea that numbers and mathematical theories are real things in and of themselves, or if they are just games that you play with signs and symbols and they have no inherent meaning in these kinds of things. And it becomes, if you're playing with these things from a Platonic point of view, then to consider all of these things is, I agree, to consider a sort of multiverse around the back, sort of from a hidden perspective. But if you come at it from a formalistic point of view and you say, no, math is just a set of characters I write and do these things, and there's no real meaning behind it, there's just, the game and the rules and the game, then there isn't necessarily a problem there.
Okay. I had another question for Matt, but I can go to the back of the line if that's cool.
Go ahead. You're already there.
Okay. Just really quickly, this one's really brief. I think there's some validity in where Luke was going a bit in terms of this idea of love. And so you mentioned these parameters of like falsifiability and testability and such. And it seems to me kind of within that framework, just this whole idea of love potentially be kind of challenging to bring about. And so the point of bringing that up is just to say that there are potentially these intangible things that are actually quite valuable to our experience and to our knowledge. And so where would a concept like love fit within your framework?
So it's all about what the definition for love is. And the fact, if you're going to say, okay, love comes into it, good comes into it, all of these things, what is good? And in order to do this, you've no longer just added the necessity of a good God, you've added this new definition for good and all of the contingent questions that go along with that and how that comes about. And those sort of add a bunch of things online. And so if you're going to get to the existence of love, again, it really sort of seems like you have to assume and define love as something which already exists, which again seems to beg the question.
So again, just to make the point that you could say of any theory that it just assumes things, the point is that we then ask, what does this theory explain? And I think the point of the question was that actually you don't get any of the virtues of falsifiability, minimalism, and being predictive unless you have scientists who are honest. So the whole scientific project is built on at least some moral values, or they presume some moral values.
So
I'm not sure if I can kick that a goal, but that's at least interesting.
Well, so the thing, this goes back, this is the reason I really like special relativity as an example, because Einstein's assumptions are two: the principle of relativity, the invariance of the speed of light. Einstein doesn't have to assume that length contracts and that time dilates. These come for free with the assumptions of the theory.
Right.
They come in. As opposed to Laurent's theory, where these had to be added as explanations for why there was no aether wind.
Right. In the context, I think what we're saying is if you're committed to honesty and truth in your principles about how you think about a theory, then you're already almost at least some of the way there to agreeing with me that love is good, and then that bit of the argument would work. You can reject it for other reasons, but that bit at least. You have then a moral value which you already believe in. You might not think it's a fundamental thing, but you're already relying on it.
So this was sort of Einstein's point with special relativity, was that we need to abandon those things we want to believe in and follow the implications of what has to be true. This was one of the fundamental philosophical things that came out of that development. So everybody wanted the ether, everybody wanted this, and this was the whole thing that Michelson-Morley were trying to detect.
Not in a moral sense, though.
But if we're going to be systematic about this, one belief versus another.
Okay.
And so I may believe that love exists on a personal level, but if I am trying to get to the base truth, I have to be ruthless. And I have to go, is it possible that I'm believing something that's nonsense? And this is a vagary of myself as a human. I could believe that I walk outside right now and an alien appears in front of me. This is under most conditions going to be a nonsensical thing, but it's something I could believe.
Okay, but I think can we keep doing this? I think you're still shooting yourself in the foot because you believe that Michelson and Morley weren't lying.
I don't have to believe that Michelson and Morley weren't lying. I can do the experiment myself. I've done the experiment myself.
Okay.
That's the big thing, is that it's reproducible.
That's awesome. Okay. Nice. Question. I haven't. I teach special relativity. I haven't bothered to actually go.
Really? You haven't? It's an amazing experiment. Okay. You can do it in the class.
Talk amongst yourselves. How do you do it?
Oh, Pasco has an apparatus that
okay.
Do it. Yeah.
That's awesome. Okay, I might try and do that before. Anyway, sorry.
I might just comment in the way of pursuit of things that we want to believe. It seems like that's what's going on with the quest for the eternal universe as well. I think we want that to be true, but we keep finding all these things pointing towards the creation, which also seems to be one of the things that would be predictability of the original statement claim made by. It seems like we keep finding things that would be predicted by Christianity. But fine-tuning seems like another one of them. A question I have about fine-tuning, and I'm another biologist wrestling with physics. So I know we've talked a little bit about the multiverse, and I wrestle with why we've looked at this metaphysics of the possibility of the existence of the multiverse. The initial statements about fine-tuning, when I'm first introduced to them, and I think many of us are, it seems like a lot of the definitions are, oh gosh, so it's so rare that this would happen, or the chances or odds of this occurring are so great, and one of the easy sophomoric things would be to say, so therefore there must be this God. But I realized then, as I studied more of it, that there's this mathematical statistics that leads atheist thinkers to say, gosh, you're right, the chances of that occurring are more than like the number of molecules that exist in the, and which I still don't understand how on earth you guys figure that out, like there's how many molecules there are in the universe. But we, right, but we say then, so therefore, because those chances are so great, there must be other universes, henceforth the support for the metaphysics of the multiverse. And so I've always talked to Christians about this, but I'm curious about if I'm even saying a coherent statement about why we have developed the idea of the multiverse based on the chances that exist, that fine-tuning seems to bring out, that makes this implausible, that there must be some other reason, either a design or more chances.
You want to know what I really think about how we came about that?
No. Actually, I don't want to know what you really think. I'd like to know. Yes, of course.
No, just like, how did we come to this idea?
That was funnier than anything we've said. Go.
From my experience, and admittedly, I'm a very young physicist, my guess is that it came out of sitting at places like this, drinking beer and going, what do we have to do? Okay, well, maybe there are all of them. How do we do this? Okay.
So you say that, but I mean, it seems like at the end you get to the point where a true academically honest atheist says, okay, I won't believe in God, and I think that actually many of them have said, I'd refuse to believe in that intelligent design portion, so therefore, you're right, the odds are too great, and so there must be more universes. Is that accurate?
I don't know that I can speak for other physicists in that regard.
Just the physicists. I know you sit right in the middle, but when you look at the physicists sitting over there, right?
I mean, I don't think that they make, like, one of the things Dr. Barnes says is that, he makes this argument that design and the multiverse are not necessarily mutually incompatible with one another. And so I am not aware of anyone who goes, I reject the existence of God, therefore I accept the multiverse. There are generally two different lines of reason that go into that. One would be like, and those, if I ever were to meet someone, I would tell them you have just committed a logical fallacy. Because the one, I don't personally see that if I reject the existence of God, I have to accept the multiverse, simply because that would preclude the existence of other possibilities beyond the multiverse. But as far as how people get to thinking about the multiverse and these things, there's this thing called the black swan fallacy, which is all I've ever seen are white swan, white swan, white swan, white swan, white swan, white swan. I see a billion, trillion, 10 to the 80th is usually how many atoms in the universe we propose, right? 10 to the 80th?
About that.
Something? And so let's say I see 10 to the 80th white swans, and I go, okay, all swans are white. So this is a fallacy. So this is the difference between inductive logic and deductive logic, and the distance between likelihood and necessity. And there's a gigantic chasm that occurs in the study of logic between these two things. And so, when you have such likelihoods, you go, okay, let me think about what else may be here in order to, fill this explanatory gap that I suddenly see. But I don't see that with either the, like I said, I'm not necessarily convinced by the multiverse and that there isn't another explanation out there which may be better, which may later be subsumed into the multiverse. I don't know. It's not my personal area of expertise. And as I've said, if I don't know the answer, I prefer to just stay mute on the subject.
So the question of why people thought that the multiverse was an idea to go after is a sort of sociological, psychological question. So it's interesting, but it doesn't totally, you wouldn't base too much on it. I can think of someone who quite simply says, well, the idea of God doesn't exist, so it's got to be a multiverse to explain fine-tuning, and it's my co-author Geraint. If you want to go and read the book, that's exactly where he ends up. So I think that's fairly common. I think the idea behind that for Geraint would be something along the lines of, just to jump over that side for a second, he thinks that there's sort of too many ideas of God, that, it's sort of a hodgepodge of ad hocness. So that would be his reasoning there. But I don't think that's something I can fault the multiverse for. I don't think it matters where our ideas come from, because there's an initial creative step in every physical theory where you go, what if this was true? And then you try and think through it all. We have ways.
You need to think that that would be true, unless it seems like the statement is that it's so finely tuned that it can't. Why can't Geraint stop there and just say no God, just what we see?
But he still
happens to be finely tuned.
Yeah, fine tuning still says to the physicist there's something here to be explained.
Right.
Okay. So the question is, what could explain it? And there's a point where you go, all right, let's just go looking for every opportunity and every possibility, and the multiverse could explain it.
Right. Okay. So that's helpful, right? So it still leaves something to be explained. Can't be self-contained.
That's
to say,
yeah. So
there's enough here to stop. Okay.
Yeah.
Question submitted online by Dr. Tim McGrew for Luke. I'll skip the one about Vegemite.
No, don't, please. It'll be easier than his next one.
It's a statement Dr. Luke Barnes must acknowledge the normalizability objection. What in the world?
Okay, well, I threatened him this afternoon on Facebook. So that's what's going on there. The objection is this. We have these numbers like the mass of the electron, the strength of gravity, and it seems like within the theory they could have an infinite range, and then there's a finite range that permits life. And that's a problem, because if you then say what's the probability and you compare finite range and divide it by infinite range, you get either not a number or zero, or it's infinities. We don't want to start doing that kind of thing. What I'll be talking to McGrew about when I meet him on Friday, hopefully, is my response to this is that if that is an objection to fine-tuning, it's an objection to any attempt to derive any consequence from a theory with a free parameter. Because the important part of that was just the infinite of one versus the other. Whereas if I then try to not calculate the probability of life, but of any data at all, the probability from some theory that atoms exist, that too would be something over infinity and be completely undefined. So at best, this is what's called the normalizability objection for various reasons. At best gives us a reason to rule out theories which have an infinite range. So if he's right, it's not that fine-tuning goes down the drain, it's that that whole theory goes down the drain because it can't tell us what is likely or unlikely. It can't give us any probabilities. This is my basic response to this. The way that scientists handle this in practice is a bit sort of pragmatic. If you've asked what seems to be a sensible question and you've got a stupid answer, go and find a sensible question that has a non-stupid answer. So you just get on with trying to boil down the problem you want to solve to a problem you can actually solve. It's a bit pragmatic. So I'd say, actually, in the case of a lot of the theories we have, the range is not infinite. The theory itself confines itself to a finite range, and then we're in business. That's all we need to do.
This is pretty much exactly why I didn't ask this question. So, because I managed to convince myself of that while working through the whole thing. That, and by definition, like the other thing is that probability theorists have dealt with this question for a very long time.
Yeah.
And the definition of distributions gets around this problem quite beautifully, is that you can have something over an entire infinite space and normalize that so that for the entire thing, the whole probability is 1. This is what the whole modern study of probability from a measured theoretic standpoint is about.
One thing often brought up in these sorts of discussions is the fact that the universe tends to be somewhat hostile to life in a lot of areas. Like, I'm not a physicist. I think it's like 99.99 some areas of the universe are inhospitable to life. You were saying that if a God exists, it would be reasonable to think that the universe would be life permitting. So I was wondering if the fact that the universe oftentimes isn't very permitting for life would throw maybe would lower kind of a Bayesian analysis of whether or not this universe was created by God.
Right, so just for that passing thunderstorm, let me repeat the question. Is the fact that the universe is mostly hostile to life a problem? So you say to some people the universe is fine-tuned for life, and they say, what the hell are you talking about? 99 point whatever % of it will kill me. Okay? So the answer to that, I think, is just what you'd want to compare there is the probability of hostility given God versus hostility given naturalism, is what you want to say. And so, given that naturalism is, as I've argued, at the mercy of all those possibilities, most of them would be hostile as well. So it doesn't seem that there's any sort of advantage there. The problem is most of them are completely hostile rather than just mostly hostile. I don't find it, the question you come to ask is, what is the likelihood that God would make a really big universe, a universe that's a lot bigger than us? And I don't see any reason why God would make a human-sized universe for humans, right? It would be good to keep reminding any finite beings that they are finite beings and dependent on God. And so a great big universe that occasionally just knocks them down a few pegs is something that is a good God might understand. So, might do. If it's not that we can predict that, I don't want to make any claim that strong, but we can at least understand it. So C.S. Lewis makes the point that what do you want, a universe which is cozy? If it's cozy, then it wouldn't give us that terrifying sense of the infinite, which in the history of sort of civilization has given a lot of people the infinite, the impetus to think about the infinite and God and all of those sorts of things. So on top of that, in the book, there's a few points that we do understand why, within the system of laws we have, why the universe needs to be big and empty. It's basically because we like gravity the way it is, but if you make a universe which is filled with air everywhere and keep the laws the same, it recollapses by about this time tomorrow, which is probably a bad thing. So we can see a reason for the hostility of the universe. And to be honest, if the universe is trying to kill you, it's doing a really bad job, right? Unless you have a vertical leap of about 8 kilometers, sorry, 5 miles, the vacuum of space is not coming to get you. So the hostility is purely theoretical. We live our lives completely oblivious to it. So it's not an obvious design flaw of the universe. No one's dying because of it.
I guess it seems like a little bit of a violation of an expectation of what you'd expect from a fine-tuned universe for life.
think at worst, I can just say, yeah, let's knock my probabilities down by a factor of 1,000. I mean, the probabilities on the other side, I argued, were like 10 to the 100, so sure.
I have a statement about that, and it's not my statement. I must quote from one of the most famous physics debate combats of all time, which is between Bohr and Einstein on the subject of quantum mechanics, and tell you, Albert, do not presume to tell God what to do with his dice.
Sure. Yeah, so I'm not going to say that we can predict everything that God would do, but at the same time, to make this argument work, I can't just be totally oblivious. So I've tried to base that on very, very basic, as little as I have to assume, love is good, things that love might be a good thing to make. That's, I think, all I need.
All right, just really appreciate the interchange here tonight. It's a bit different than some other fine-tuning discussions. You guys are getting in all kinds of interesting things, so great job. But I guess I wanted to understand a little bit more, Matthew, concerning just the fine-tuning claims itself, like say the cosmological constant. So we seem to have this wide. Do you dispute the range of possibilities being as broad, or the life-permitting range being as narrow? Or do you claim that we have some information that would, it seems like a principle of indifference would, if we don't really seem to have a real constraint that pushes us into the life-permitting region. So it seems that there's some argument that it's an improbable state for life. How would you unpack that in your analysis?
So, as I've said, I'm not a cosmologist, and so possible ranges for the cosmological constant, as far as I know, the base assumption is that the cosmological constant is a real number, and then we need to pick the appropriate real number. Like on the
contributions from quantum field theory give you this 120 orders of magnitude more, right?
So as a professional physicist, I have a responsibility not to comment on things about which I am not an expert, and I'm not an expert on values for the cosmological constant. I think there are people who are much more qualified to speak on that subject, and this goes back to my whole thing about trying to be minimal about things. I don't know, and I can't give you an answer on that because I don't have enough. I've read some of the papers that try to bound what these values can be and determine they are small. And I can see and I can follow those arguments. I can then read people who criticize them to some extent. From what I understand, there isn't much dissent on the fact that if values were terribly different, then our universe would look a lot different. But that doesn't seem terribly remarkable to me. That seems pretty straightforward.
So, what do you think about Luke's claim that a change of one part in, say, 10 to the 90th would have rendered there no structure at all in the universe and that kind of a thing?
I think that if I went through and I made sure that I understood the models for inflation and other things that were being used for that, and I went through and I did the simulations, I would probably not end up with different results than he does.
I assume that
you're competent, right?
Yeah, totally.
Yeah. Okay, so.
In my own research, I've tried to find, skeptics of it seems to be pretty widely accepted among all scientists, the kind of things he's claiming. So sure. I was just curious, because, these, you seem to be then acknowledging, although you're also kind of hedging like you're not sure.
Well, and that's the thing, that's sort of my responsibility, is to hedge, because I don't know. And as a professional in this arena, I have a responsibility, as a matter of professional ethics, I think.
Sure.
Not to make statements I cannot personally verify, so that somebody later goes, this physicist, this mathematician said this thing. I'm like, no. I am not that guy. I am not going to make such proclamations.
Appreciate your moral stance on that, by the way. Okay, so
sorry, a bit late, but yeah, that was good. Like half of you were there before me. Carry on.
Sorry, I didn't mean that as a slide or anything, but you mentioned like the confidence interval and so forth. It seems like when you're dealing with 1 and 10 to the 90th, you don't really worry too much about exactly where the confidence intervals are. And
well, so here's the thing. So let's take. We're going to take this thing we call an icing model. And really it's just a set of particles that can either be up or down. And we arrange them.
Icing is the name of a person. It's not icing on a cake.
Not ICING, ISING. And we arrange them in a gigantic grid. And we put something like, 1,000 or 10,000 of these different things in here. And I ask, well, how many different possible ways could I put this together? And let's say we even put more. Let's say we put some number. In physics and statistical mechanics, that number can be, rather than 10 to the 90th, that number can be 10 to the 10 to the 90th. And so we have this notion of very large numbers, and things get very big. And so the fact that something is large is not terribly scary if I've been trained correctly. Like, large numbers occur. Like, this is just something that's there. So Avogadro's number is 10 to the 23rd, not quite 10 to the 90th, but it is the same kind of number from a mathematical standpoint, and it has some of the same properties. And so dealing with these things really sort of happens every day, and we don't think about it or even know about it. But I'm not, the fact that it's 10 to the negative 90th, unless I have some reason to think something more, it doesn't really mean a whole lot.
Okay, so the inference, it seems to me that sometimes you seem to be appealing to expectations that future knowledge will minimize this fine-tuning. It seems to me that's almost like a naturalism of the gaps or more of a presupposition. Is there any basis you could point to for expectations that the fine-tuning would change?
Well, so there's an example. So there's this thing called the Rydberg Formula. And this guy named Rydberg, back in, I want to say, like 1887 or whatnot, he was studying the spectrum of hydrogen. And he found out that if you look at the excitation spectrum, there are these different series of spectral lines that you get, different energy levels in these things. And he was like, well, I can come up with a formula for these things, but I need to add this number. And this number, comes in. And it was just like totally, this is just totally empirical. Here's where my number comes from. And then later on in about 1901 or 1905, sometime around there, Niels Bohr comes in and he's playing around with things. And he goes, well, let me construct my model for the atom. And in this model, tell you what, let's work with this assumption. I'm gonna steal a page from Max Planck, and I'm gonna say, well, what if energy is quantized, and what if angular momentum is quantized? And when you properly go through the derivation for this model, and you properly go through the implications for the quantization of angular momentum, you get the Rydberg formula. It pops out as a result. And I can't say, so the Rydberg constant is a bit different in that the Rydberg constant has dimension. But there are, I can think of all sorts of other places where, we have numbers that show up that we later have an explanation for. And if I don't need to assume that there is no place that these numbers will come from, I don't see any reason to make that assumption.
Okay, thank you very much.
Okay, playing ping pong over here. Coming from the information sciences, I can sympathize a little bit with each one of your positions. On the one hand, it seems like every time I know an algorithm and there's always some other factor that I didn't know, I thought such and such was reality, there was something I didn't know, I have to refactor the algorithm. It seems almost ad infinitum, so I can definitely understand, are we ever going to get to an answer? At the same time, as Jason said, I'm a Christian too, so I tend to wish, I like the idea of seeing footprints of God, as it were, or things that seem to be fine-tunings, but at the same time, it would be so much easier if he'd just show up and eliminate all doubt. And coming from the information sciences, that I ultimately have to get out of the cloud and deliver something. Are we ever going to hit a point pragmatically? We've talked about pragmatics and Occam's razor and necessity and all that kind of stuff. Do we get to infinitely keep waiting, thinking, I don't want to choose this answer because there might be a better explanation for it, so I'll infinitely keep waiting? At this time, well, I don't know if God's going to show up. At what point do we collect enough fine-tuning arguments where you have enough million to make the question moot, where people can make a conscious decision? But where do we all go with that, since we don't have the time for the computing systems to be in place to hold all that stuff down? What's the pragmatic action we're going to take on this side? Wait forever, or are we going to amass enough fine-tunings? What do we do as people? What's the practical application of the science?
So the point of the chalkboard analogy was not really, I don't think it's essential to the argument that at some point we will actually be in that particular case. So you might, even the chess pieces, if they're, they observe the games around them, right? They could Like, think about the really rare moves in chess, like castling or something, right? You could watch chess games for ages and never see that. And then you see castling and you think, oh no, we've got to rethink our laws here, we've got to add something more in. So at any point they could say, there might be something we just haven't seen yet. The point of the illustration is to say, on naturalism, there is some ultimate set of facts about the universe. And let's just imagine we could write them on a board. I don't think it's essential to the argument whether that's actually the case. It's a thought experiment, okay? There are no infinitely large, conductors. There are no frictionless planes, all the sort of assumptions we make in physics, the approximations. The point is to try and think through, even if there is some set of basic facts about the physical universe, because there are facts and we can just mentally put them all in a great big pile. If we had all of those, or even the most basic ones, would we be happy to just say, that's it, that's reality, we're all done? So the point of the chalkboard is to just try and imagine a scenario where we can at least imagine them all in one place at a time and then think through what that would mean for us. So that's the point of the thought experiment. And so I think fine-tuning, you can be open to the idea that maybe future discoveries change our ideas. But we've had an awful lot of science thus far, and they've still left a lot of fine-tuning. Now, it's entirely possible on naturalism, and it seems to me likely, given all the other mathematical possibilities, that at the end of the day, we will have the case that there's an awful lot of ways to make a universe which is dead and not many to make one that is alive.
Okay, I'll begin my question with a little bit of self-introduction. My name is Jimin Zhou. I'm from China, and I became a Christian there. However, I go by the name Maverick because I like the movie Top Gun. I also like Dallas Mavericks. Whatever. I also have a bachelor's degree in aerospace engineering and a master's in mechanical engineering. Well, anyway, so my question for Dr. Matthew is, I kind of have a sort of non-question though. So I personally think if a person is totally materialistic, then when you're put in some certain situations, then I think you'll definitely end up being socially Darwinistic, because there is this mathematical model called game theory, developed by the famous mathematician John Nash Jr., who is described in a beautiful movie and novel called A Beautiful Mind. And in fact, so the game theory, so the zero-sum game theory means in order to win the game, you have to make someone lose. You just have to. In other words, your success is based on someone else's failure. In other words, this is no different from social Darwinism. And in fact, game theory is widely used in international politics and economics. And this also has something to do with how I became a Christian in China, because I don't like our educational system, which teaches social Darwinism and Marxism. Because we are often faced with, in China and India and Japan and Korea, we're often faced with zero-sum game theories, which means if we want to succeed, if we want to obtain some objects, some material, we just have to make someone else lose. And
what's your question, sir?
Yeah, so if you're put in situation like you're born in China, or you're born in the period of time where the Americans' economics is depressed, in the depression, which means supplies supply is less than demand, which means it's a zero-sum game. How do you, in this kind of situation, how do you define love and hatred? How to define morality? How to define what is good and what is wrong? And or do you simply think, for no reason, you're luckily born in America, or you're not born during a time of depression?
So your question is, if I am materialist or physicalist in my position, how do I consider anything but my own self-interest?
Yeah, exactly.
So there are a few things to do that in. First is that so you're familiar with the prisoner's dilemma, I would assume. So the prisoner's dilemma is that there are two rooms with two prisoners in it. So, and if you tattle, you get to go free. So if you tattle and the other person clams up, you get to go free. If they tattle and you clam up, and I'm doing a horrible job of this, I don't remember the exact parameters, but then you do 5 years and they go free. Or if you both tell, if you both clam up, you both get 3 years or whatever. The question is whether or not you are going to serve yourself or you're going to serve someone else. And as far as I know, there are altruistic algorithms for this particular thing that are amazingly successful. And so it's not necessarily true that in every situation the best way to get your own outcome will be to screw the other guy over. This is the whole point of Nash equilibrium, is that you can't necessarily act to screw the other guy over or to press your own advantage. There are what are often really bad outcomes, but that are not the worst outcomes that occur for anybody. And in fact, this whole idea from John Nash of the Nash equilibrium is that there are plenty of games where nobody really loses, nobody really wins, but nobody really has to lose. And this is part of how I think we've gotten to move forward. I also think that the idea that the only way to succeed in impoverished conditions is to ruin to yourself. The development of civilization occurred because we got to develop farming, and with the development of farming, not everybody had to be to work on subsistence, and so specialization was allowed. And with the allowance of specialization, we got the development of cities and other things. And so this whole this acknowledgement that we are stronger together is pretty well rooted and pretty well grounded ethically without having to make any sort of other appeals. So if I can work with someone else, I can often compute that I will have better outcomes working with them than if I try to just totally screw them over and get everything myself.
Yeah, well, yeah, there are many non-zero-sum games. However, I'm talking about, there are places in the world, like China, India, people are dying every day just because they don't have enough food for everyone. And
so your question seems to be, how can you have compassion then without believing in something more?
Exactly.
Why do I have to believe in something more to have compassion? My compassion doesn't have to go out from some belief in God or anything else. I can have compassion because I can know what it was like to have been in a bad situation and to understand that I don't want to be there and I should not want someone else to be there. This doesn't require any further explication. I can construct an ethical and a moral system based from this experiential point of view.
However, if you are put in a situation, a zero-sum game, where either you survive or someone else, as a totally materialistic, and you don't believe God, how do you define what is love, what is good?
Probably so. I mean, again, I don't need a conception of God to have a conception of what love is or good is. I can understand from a metaphysical standpoint that the definitions for these things are sort of murky without having to make reference to the existence of God. But if I'm involved in a zero-sum game, what is good? Well, there are, what's the game? So if the game is that I'm sitting up here and, you know, either I eat a hamburger or some kid in Africa, you know, gets to go to school, that's no question. So, you know, what is the weight of these outcomes? You know, what is zero sum? You know, if I'm going to lose and someone else is going to win, what is the weight of these different things to each of these different people? So if my loss means that, you know, I get my head chopped off, and my winning means I go free and the other person gets a slap on the wrist, well, you know, these are unequal outcomes. As far as, you know, if you want to bear this down and push it into the most possible abstract way where it's a zero-sum game, me against someone else, me against someone else, you know, and both of us will die at the end. What I will point you to is a quote from Art Spiegelman's book, Mouse, which is about his father's journey through the Holocaust. And he talks about at the very beginning, in the very first pages, he is roller skating, and he falls and he skins his knees, and his friends goes off, and he runs to his father and he says, "My friends left me, and they did all of these things." And his father looks at him and goes, "Friends? Lock them in a room with no food for a week, and then you will see what is friends." And, you know, the things that come out of that, you know, the story shows that he shared when he didn't have to, when it might have meant his death. There are all sorts of ways in people that you can have good character without necessarily having to have a belief in God.
Okay, and also for Dr. I'm sorry, I'm not good with names, but
they're all pronouncing it wrong anyway.
Okay, yeah. So anyway, you know, people in China, lots of people in China, they don't believe that Jesus can feed 5,000 people, and they don't believe that God can send manna to Israelites, and they don't believe that God can provide for all the beasts in the world, and therefore how can he not provide for humans? And what often happens is, you know, lots of high school teenagers commit suicide every year just because they don't score high enough in college entrance examination, and some people commit suicide just because they're no longer number one in class anymore, right. Or someone just kill his classmate because his classmate is number one in class and he's jealous of what he can get as number one. So how do you answer to people in China and India? How would you tell them that, you know, there's a God who can provide? And
yeah, that's a huge question. The answer is not with a telescope. I'm an astronomer. Let's just all remember that for a second. There are a couple of questions there. One, how if they don't believe that God could do miracles, then their idea of God is too small. I mean, the one thing I think we should be able to agree on is if there is an infinitely powerful being, then feeding people is something that being could do. The question is whether there is actually any kind of being like that. Within theism, there isn't the set of, here's the stuff that science explains and here's the stuff that God does. It's all the same stuff. There's the stuff that God does so reliably and consistently that we can describe them mathematically. That's science. There could also be things that God does that break those laws for a special purpose. We're only going to answer that from history. So it's a question of whether God, if you think that God exists on the basis of whatever, you know, fine-tuning argument or whatever, whether God has actually done anything is you're going to need some good evidence one way or another. So it then boils down to the historical claims of any particular religion. So the answer to the question is evidence. How would you convince people? Hopefully evidence.
Thank you. Real quick, we are at time, so we're going to do lightning questions with lightning answers. Last question over there, these three over here. Go, sir.
Okay, so sorry about my parents. I got a gig next door. So that being said, I missed good portions of this, and if my question was already addressed Just tell me that, and I'll find it on the web afterwards. So from what I understand, and my intelligence obviously being well below the median of this room, is that like thermonuclear dynamics, the laws of which would make it to where an explosion, like the Big Bang that would happen in a vacuum, would accelerate at a continual or even accelerated pace. So the fact that our universe expands and breathes, doesn't that prove the existence of God?
No, not necessarily. I'm on your... So,
Success!
I'm out of beer. There is no God. Sorry. If you think naturalism is something that makes sense, then any kind of natural universe could be something that exists. So I don't think you can fault the naturalist on that regard. If you think that whatever exists needs an explanation that is, self-consistent or which ties off the end of, but why that explanations, then you're never going to get that from naturalism, so you better look somewhere else. The case I've been making tonight is that one reason to not stop with the ultimate laws is because they just leave you at the set of a massive, at the mercy of all these other possibilities with no way to choose between them, and that's not something that a good explanation does.
Speaking in front of us. It's been enjoyable to listen to both of you. The first question I have for you, Matt, and I may have a second one depending on what your answer is first, is in your speech, your first one, you said that you were a non-atheist or an atheist. And in your first question asked, I don't know who the person was, they asked, do you believe in design by chance or whatever? And you said, I have the privilege of not deciding. So my question is to you, are you an agnostic or an atheist?
I don't know. I mean, I hate to blame Jason for the fact that I identify as an atheist these days, because for a long time, like, I accepted the notion that, so a God of goodness is sort of a minimal construction that we get from Anselm and these sorts of things. And then I had to ask the question of, okay, where does, what is good? And, pose the existence of the person whose moral values was totally inverted to whatever else happened. And that seemed to break things down. So if I could not, if I could not decide the proposition between the two of them, then, that particular construction for God doesn't work. Because actually, so we talked about Gödel earlier. Are you familiar with his ontological argument?
Oh, I know that it exists.
It's airtight. Like, you have to attack the as with anything Gödel does.
I don't think the ontological argument is successful.
Anyway, as far as of this moment, do I think that God exists? No. Just like on a personal level, do I know? I don't know. So having an opinion, having a thought based upon what I know at the moment is different from having certainty. And I generally don't think I have certainty with respect to much of anything. So this whole, it gets very dark if you can't be certain about much of anything in the world. The world seems to get very dark and very hard.
Do you love your mother?
So, that depends on which day you find me.
Oh, I love you.
He loves you.
Yeah.
But it's more, what I have to do more is deal with this uncertainty and figure out how to live with it and how to find the best explanations I can when I find them.
Really quick here. If you have uncertainties, why would you attempt, just curious, why would you attempt to come and argue or debate on the subject rather than just listening and try to find out on a personal level?
Because I'm Socrates throwing verbal rocks at these mediocrities. So
shooting down someone who thinks they know something when they don't actually know something is just as morally, just as intellectually defensible as trying to build something up.
And investigation by interrogation. So I told Dr. Barnes earlier, I'll tell people that part of the reason I agreed to do this is it's not a conversation that I've had. I don't, I haven't specifically thought about fine-tuning before this. You know, I've had lots of conversations about these sorts of things before, and you know, a lot of them sort of go the same way over and over and over again, which sort of leads to some entrenchment. You know, but there were new bits, so, and that's fun. So I agreed to do this because I got to learn things, and that's what my whole worldview is about.
Mine will be quick and fine-tuning related. Can you tell us about the fine-tuning of the initial conditions?
Yes, I can, but not quickly. So there's an interesting case of whenever we try to explain things in the universe, the second law of thermodynamics is basically the scientist's way of saying things tend to go from a state of order to disorder. So the ice in your glass will melt because that is a less ordered state, and if you let things jumble around, then it'll go to the, a more ordered state, it'll go to the less ordered state of just being ice and of just being water. What that says to me is, and it's kind of interesting, is that actually all the successful scientific explanations of galaxy formation, star formation, planets, everything we've done, all the thermodynamics, starts off with the assumption that the universe is in an ordered state. And the sense of order there is a very specific thing about, you know, that we need in statistical mechanics to explain a whole heap of other stuff about the universe. So that's not it sounds like a fluffy term, but it's actually quite precise. So what that suggests to me is that, you know, again, thought experiment, but when you put Alberta's board up there, it's going to say something along the lines of the universe began in a highly ordered state, which would just be another thing on that board which you would not expect of a typical universe, or it is something that by any sort of measure we could get from science seems unlikely on naturalism, but more likely on theism, where you need order in order to have any sort of life form we could ever imagine. That is the initial condition of fine-tuning the initial conditions.
Hello. I have a question. It's a little bit, because I don't know really a lot about science, I think maybe I'm asking a basic question. Like, I don't really know why it's important to have a universe to have life. And if the life is going to be like carbon-based, maybe there are other kind of bases. Like I read sci-fi books and they assume there are other kind of life. And is anything related to people or not, or it's just we like that to be a way, like we like everything is like about people and good and evilness and stuff, but maybe it's just our imagination, like it make us feel good, so we have this kind of assumption.
So often cases of fine-tuning focus on carbon. The reason for that is not just because we're carbon and it's familiar, it's because carbon is by some considerable distance the most versatile of all the chemical elements, just chemical, many ways you can put things together. Having said that, I haven't actually assumed that all life must be carbon-based. So my examples were, if you're going to make a universe with life in it, there better be some structure in it at all. That's all I need for the argument. Like, you know, a cosmological constant can totally screw that over for everyone. The reason I'm focused on life is really the data that's important depends on the theory that you're testing. So if you don't know why the surface of the Earth looks the way it is, you don't really have any theories. The fact that all the continents fit together a bit like a jigsaw puzzle, is that a special fact? That question doesn't really have an answer. It becomes special once you have a theory to test. If you think that the continents just sort of bubbled up where they are at random, versus they were all one supercontinent that broke apart into and sort of shifted around the Earth. You have a theory of plate tectonics. Now that's a really special fact because it lets you decide between the two. So the argument I'm making is that life is not a priori special. It's special with respect to the two theories we're testing. Life is a good state of affairs, and so is something we would expect God to create. That's the argument I'm trying to make.
I'm kind of lost. So you mean it's special because it's kind of special?
Yeah, a bit of data is special to a theory if it's what we would expect on that theory, if a theory can explain it.
Which again is like that's the thing. That's the dividing point when you have two competing theories is find a point where they differ. Hopefully you can measure it, and once you do, you should be able to determine if one or both of them are incorrect.
Okay.
But which again, just to go back to the whole thing is that you get, I say, if one or both of them are incorrect because if they both predict the same thing with differing likelihoods, you haven't really shown the validity of one over the other. So if if both make a prediction, one is more likely than the other. One says that this prediction is more likely than the other. You haven't falsified it in particular. Like I said, I like the ether as sort of a turning example on this, because you really falsify the existence of ether with the competing.
I can accept that.
Real quick question submitted online by Gordon Rock'em Sock'em Rhodes.
I have a question about Dr. Matthew's materialistic world. How big it is. There
Enormous.
There are maybe two different answers. Like one is finite size. Another way is infinite size. If it's finite size, how big the world it is, and what are the things outside of the universe? If it is infinite size, it seems it cannot be happening in the pure math, because there's a infinite. If there is infinite big, there should be infinite small. If it is infinite small, there should be nothing. I think it's not you like, because if it's nothing, it will lead to a big gap from nothing to exist. So how do you think about this?
So your question is one whether I think the universe is finite or infinite?
I mean, how big I think the topic today is that one way argue that the source of the universe is from God, and another one argue the source of the universe is material. So I mean, how big the world, the universe is. I mean the size.
I think the universe is very, 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 very big.
Can you say that again?
Very, 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 very. It's so we have this notion in physics of the light cone, which includes everything. Essentially, you're going to correct me on this if I get it totally wrong, but basically includes everything that we could ever possibly observe from where we are in the universe. So things beyond our light cone are too far away or moving too fastly away from us for us to be able to observe them. We can't see anything outside of our light cone, I believe is the appropriate way to put it. And so we have our light cone, and we can look inside of it, and we can wonder what may be outside of that. And the thing is, by definition, we can't see that. And this is, there are all sorts of explanations for what could be there. I think that we can suppose answers to that question, but if we can never observe it, no matter how intellectually satisfying the answer to that question we come up with may be, how utterly compelling it may be, if I can't know the answer, I think about, should I spend my time on this problem, or should I spend my time thinking about questions that I might eventually know an answer to? And
your answer about the size of the universe is infinite big.
So
it's a question for cosmologists, and cosmologists don't know. I think
it's pretty much exactly what I'm going to say is I don't know how big the universe is.
That's my answer as well.
Just think the universe is infinite big. but the element consists of the world. Can it be divided into very, 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 very small, and until to nothing?
So here's one of the cool things that Dr. Barnes brought up is we have this notion of the Planck scale, right? Okay. So we can know, we can make smaller and smaller measurements, but as far as we know at the moment, there's a limit below which we have no resolution, below which we can't know if there's anything smaller because of the way that the laws of the universe work. Likewise, if we go to the very, very big, there's this thing called inflation, which says that all of the points in the universe are simultaneously moving away from each other like holes in a piece of bread as you bake it. So all of these little air bubbles, they just move further and further and further away. And so how big is the universe? I don't know. I know that the universe, as far as we know, continues to get bigger all the time. And I think that's a wonderful thing. And I can know that, and I can ask questions about how does the universe get bigger all the time? And I can learn more about that, and I know how much smaller can we make, and how many things can we do when things get very small? How weird does the world get when we look as tiny as we possibly can? And I find both of those questions absolutely fascinating, and I think that they are answerable. And I think that I can get a handle on them, and I think that there's some way that I can know in a philosophical, in an ontological sense, what those answers are. And so my thing is that I can know the truth value of those particular propositions. And if there are so many of those questions that are out there that I haven't even asked or tried to answer yet, I want to work in that space rather than in the space of questions of what lies outside my universe. I can't know what's outside of my universe, but what lies there? So it's a big green dragon. Seems about as likely as anything else.
Last question from Gordon for Dr. Titsworth. If you literally saw Jesus rise from the dead, shouldn't a materialist believe that because it happened in the material world?
So if Jesus literally rose from the dead, so we recently discovered how to unscramble an egg. So scientists recently did that. This was something that came up. And so, on that particular question, I could conceive of a thermodynamic process which allows it to happen, however unlikely that thermodynamic process is. The version of this question that I think gets really asked and would put things, well, is I think more a matter of if God came down and stood in front of me and said right now, I exist, do you believe that I exist? My answer would of course be yes. So if that were to happen, of course, now I can say, nope, I was wrong, there's this thing, here you go. So the question is whether or not I can know that answer.
So just quickly, it always intrigues me when you ask an atheist, what would it take, or whatever you are. We covered that. What would it take for you to believe in God? They pick something which it could very easily be written off as a hallucination or something a sufficiently powerful natural thing could do. Whereas if you wanted evidence of the kind of thing that most people think God is, that I was talking about, necessary being who created the universe and is good, the kind of evidence you would need is exactly the kind of thing you get from the cosmological argument, that we would need an explanation for existence, and the fine-tuning argument that there is something, even when we got to the bottom of the laws of nature, that would still require an explanation. If you're looking for an answer beyond the physical, you need an argument that naturally draws you there, rather than I saw something out my bedroom window one day. But I think it's more of a psychological fact about people, about how you guess how you would react to certain things. Well,
and it's as soon as you move to and I think the response is pretty standard, that as soon as you move from the non-physical, you run the risk of defining the thing that you want to come up with. And so,
sure. So go through this debate again and see if that's what happened.
Yeah.
Closing statements, 2 to 3 minutes.
Do you want me to go?
Sure.
Let me come back to something that was said in the opening statement, just to finish this off, because I think what I'd like to leave you with at least is a clear way to think about God. One of the things that was said was that we consistently find physical explanations and that supernatural explanations turn out to be wrong. If you look back in the history of science, the people who really plumped for there is a precise and knowable order underneath the natural world were really, if you look at the scientific revolution, were the Christians. And so guys like Francis Bacon, who thought because there is a good God, there will be an order underneath the world we see around us. It is something that we might expect to, if we're careful enough, to discover. Now, Francis Bacon died from pneumonia that he caught while shoving snow up the rear end of a chicken, right? The reason he was doing that was to test whether it was going to preserve the chicken. The reason that's relevant is because if you don't know how the world works, you really have to kind of try everything to try and see a pattern somewhere. So the ones who historically got off their backsides and shoved snow up chickens and did the hard work of saying, let's try and find an order underneath the universe, are the ones who were convinced that a good creator made it. So the fact that those people went looking for consistent physical explanations for physical events because they believed that a good creator was behind it, the fact that they then found them and voila, we have science, I don't think then comes back to bite theism on the backside. Behind the fine-tuning argument is the question, why are there any physical laws at all? Why is it that we can go out and do science? And I think that that too is something that, you know, if random sorts of events, so there's more ways to be random than there are to be non-random, then you might expect on naturalism there's more ways for the physical world to be completely chaotic rather than actually discoverable. So in that sense, the discoverability would be another thing, and I would suggest is a very important thing that theism could explain. The fact that we can do science at all and have this kind of discussion is historically both a thing that came out of those theistic convictions and something that sits well within them.
Dr. Luke Barnes.
So my final statement is that the universe is very big, as I've said, and that there are a lot of things that we can both know and not know, and we can be Donald Rumsfeld and have known unknowns and unknown unknowns. But that whenever we try to limit the end of what we can know, we continually find that there's more underneath it all. We scratch the surface. Dr. Barnes previously used the example of whether or not there is a self-supporting rock at the core of the Earth or whether or not it's Earth all the way down. And it may be that eventually, as we keep scratching through these different layers and go and we go and we go, we may eventually find a self-supporting layer. We may find something at the very bottom. So, but as far as we've gone so far, and I think that we are only just scratching the surface of the crust of what exists in the universe, everything we've seen so far and all of the evidence we have is that there's more and more and more still to go at the bottom. And the thing to do, in my opinion, is rather than go, I wonder what at the end of all of this, is to keep scratching and to keep looking and to keep digging further and further and down and find what the next level is and find the wonders and find the mysteries that this presents to us so that we can, from there, we can figure out all sorts of new things until we get stuck again and we have to scratch through until we get to the next layer. And that, I think, is a noble pursuit. And we have to keep questioning. And it may be, it may be that somewhere along the way we find the self-supported center. But we aren't there yet. And if we're not there yet, I don't want to make any assumptions about what that is supposed to be.